Hi guys, welcome to this video that will tell you everything you need to know about the class-based, object-oriented programming language Java. Java is an object-oriented programming language that is used in a distributed environment on the internet. It is a high-level language that is easy to read and understand. Java is popularly used in console, graphical user interface, web and mobile applications, game development, and also to make embedded systems. Apart from these, Java is also used to develop software for devices. It is used not only in computers and mobiles, but even in electronic devices like televisions, washing machines, air conditioners, and so on. Online forms, banking, and shopping are possible because of Java. Java is a computer-based programming language invented by James Gosling and Sun Microsystems in 1991. He had a single motto while creating the language. It was write once, run anywhere. This meant that the code would have to be written only once, but it could be used anywhere. They named this language Oak because of the oak tree outside Gosling's office. Later, it was named to Green, then to Java Coffee, which was named after the coffee from Indonesia, and finally to Java in 1995. There are 3 editions of Java. Each programmer can learn any of these editions based on the application they want to make. Firstly, we have Java Standard Edition. This edition contains core libraries like java.lang, java.util, etc. Secondly, we have Java Enterprise Edition. This edition has APIs like JMS, EJB, JSP, servlets, etc. And lastly, we have Java Micro Edition, which is used to program Java in cell phones, set-top boxes, handhelds, and so on. Java is an object-oriented programming language based on C and C++. However, it is improved and simplified to solve the errors in programming. Java files are converted to bitcode format using a compiler and then executed by the Java interpreter. The whole Java code is run on the Java virtual machine, which provides a runtime environment. Now the main concepts in Java are its methods and classes. A method is a block of code that performs a task only when it is called. Consider this example. While watching TV, you use the TV remote to change channels. Each button on the remote performs a different task. Methods in Java are the same. We can have methods to add 2 numbers or email a person or to convert kilometers to meters. A group of methods make a class. Classes are used to organize code just like how fruits, vegetables, and clinical products are divided into different sections in a supermarket. There are a lot of features in Java. Let's start by looking at them one by one. It has a simple syntax and is very easy to understand and learn. Java language is robust. It eliminates errors that occur in the C and C++ languages. Java also has features like garbage collectors and exception handling. This makes Java very unique. The most popular feature of Java is that it is platform independent. Here, compilation happens in bytecode, and because of this, Java can run on any machine. It is a very secure language as it contains no virus. Java has a feature of multi-threading. The feature of multi-threading helps Java do multitasking. Java is a portable language as it can run on any platform, and data type sizes are set permanently. So Java program has a fixed size of the code. The last of all, Java is not as fast as C and C++, but provides higher performance than any other language. Now let's see OOPS concepts in Java. Java has 4 concepts: abstraction, encapsulation, inheritance, and polymorphism. In Java, we use objects and classes related to the real world that makes the code easier to make and understand. Abstraction means showing the relevant information that is needed for a task. Encapsulation makes the Java code secure. Data is stored within the classes, and it is not easy to access the data. The next feature is inheritance. As the name suggests, the attributes and characteristics of one class can be inherited by another class. Because of this, coders take less time to create the code. Lastly, we have polymorphism, which means using the same method for different tasks. In Java, we can use the same object or variable in 2 different places where their tasks will differ.
So now let's download Java. Let's go to Google and search for Java download. We'll go to the link we see here, oracle.com. So now here we have the web page. Here we can see Java SE 13. So this is version 13, but this isn't the one we are going to download. We are going to download the 8th version, version 8, which is here. Now we're doing this because 8 is one of the more commonly used versions of Java. So let's click this. And here we'll go down. We need to accept the license agreement before we can download it. Now we have two versions here, x86 and x64. Now you can download it depending on what version your operating system is. Now if you do have a Windows 10 operating system, it's highly likely you have a 64-bit version of Windows. Now if you do have a 32-bit version of Windows, you can take the x86. So let's download this. So we've actually already logged in, so we just need to run the installer file now. Let's go to downloads and run the file. So here we have the installer. We'll go to the next step. We'll select this to next. Here we can see where the file is being installed to. We'll go to next. Now if you want to change where you want to install Java, we can press the change option. I'm just going to keep it here. We'll press next and let's commence with installation. And there we go. The installation is now complete. So we don't need any tutorials or API documentation. So we'll just finish off and go to close. Now to see if Java is installed in your system, we can go to command prompt and type the term javac, which refers to the Java compiler. Now as you can see here, this shows a number of different options you can choose from. This also indicates that Java has been successfully installed in your system. Now if the installation was not successful, you'll see something like javac is not recognized as an internal or external command, operable program or batch file. But since we've done it successfully, this is what will be shown. Now we're going to set an environment variable. Now what exactly is an environment variable? Now assume you have a file which has a .java extension. This environment variable tells the computer that the Java program needs to be called to run this particular file. So to set the environment variable, we'll need to go to control panel. Here go into system and security. Go to system and select advanced system settings. And then this shows up. Now before we go into environment variables, we'll need to go to where the Java file was installed. So let's go to this PC, C drive, program files, and here let's go to Java. So let's go to JDK, which is the Java development kit. Let's go to bin here and copy this path. We'll go back to environment variables, select path here, and then press on new, paste this, and OK. Now we'll go back and go to JRE, to the path of JRE, which is Java runtime environment. We click on this, bin again, and copy this path. Select this one, new, and paste that. And there we go, the environment variables are now set. Now let's talk about running that simple program I told you about. Now this is possible with the help of an IDE. An IDE or integrated development environment will give us a platform to code Java. We will be using Eclipse and IntelliJ as they are popular and commonly used. That being said, there are several other IDEs that are available in the market. So now let's work with Eclipse. Let's go to Google and search for Eclipse. We'll go to this link, press download. And then this shows up. Let's click on download. Now we've already downloaded the software, so I'm just going to directly go into the install phase. Downloads and select Eclipse. With this, you can see that there are multiple options for you to choose from. So we're going to select Eclipse IDE for Java developers. Now you have other options like for C and C++, JavaScript, PHP and so on. But let's go to the first one. And here you have the details. You can change them if you want. But I'm just going to go ahead with installation now. Press accept now. Here we remember accepted licenses and press accept. And then here as well, we'll remember accepted certificates. Select this one and accept selected. And there you go, the installation is now complete. Let's click on launch now. So here we are setting up a directory as a workspace. I'm not changing it here, so I'm just going to go with launch. Here we have the Eclipse workspace. Now let's close this first. And here we have the package explorer. Now in case this doesn't show up, you can go to window, show view, and select on package explorer. So now let's go to file, new, and Java project. We need to set up a project name. I'm going to call it my project 1. Go to next. We'll go to source. So this is where the source code for your program is going to be stored. Then let's finish. And now we'll click on my project 1, go to source, right click, new, and create a class. I'll name the class my class and create it. And here we have it. So now let's write a simple program to multiply two numbers. So now let's write the main function. Open a bracket. Now we're going to initialize the first number. Now the second one. And finally the output. And finally the variable that will store the output. Now we'll just give them a simple print statement. Now let's run the code by clicking this option here using myclass.java. And there we have it. Here the product is shown to be 100, indicating that the program is running successfully. Now we're done with Eclipse. Now let's move on to the other IDE I was talking about, which is IntelliJ. So for that, again, we'll have to go back to Google so that we can download it. Search for IntelliJ download. Go to this link here. So here you can see that we have two options, the Ultimate Edition and the Community version. Now here the Ultimate version has way more options, as you can see here, but it's a paid version and only has a free trial. Now the Community version is free, so that's what we're going to take. So we'll click on download here. So I've already downloaded the software, so I don't need to do it again. So I'm going to go to downloads, and so here we go. Let's just click on next. Select the location where you want to install it. Press next. Now we will add a 64-bit launcher shortcut on the desktop and create associations. So basically this means that these are the different file extensions that this will support. So .java, .groovy. And now let's go to the next step. We'll install now and we'll wait. And there we go. The installation is now complete. Let's not import any settings. We'll accept the privacy policy. We'll set defaults. Now let's create a new project. So here make sure your project SDK is set to the version of Java you've installed. Make sure this isn't blank. We'll go to next. Here you need to select this option, which is the create project from template, and we are now going to create a command line application. Press next. Name the project, which I'm going to call my project 2. You can change the location if you want. I'm just going to keep it the way it is, and then click on finish. So now we're going to create a simple program through which, based on the user's input, we can determine whether a number is even or odd. So first we're going to import the package scanner through which we can take the user's input. Next, let's go inside here. Let's create the variable reader. Now let's ask for the user's input. Enter a number. We're taking in the value now in the variable num. Reader dot next int. So this is with which we'll be taking in the value from the user. So we're going to set up a condition to determine whether the number is even or not. So if the number when divided by 2 provides the remainder 0, it indicates that it's an even number. We'll show them then. Now for the else case, the number is not even. Or in this case, odd. There we go. We're done. So let's run this program. So let's enter 12. The number is even. And there we go. We have a successful output. This indicates that the program is running successfully.
So what is Java? It is a fast, reliable, and secure programming language that can be used in several websites and applications. It can be used to create applications in a single computer or one that could be distributed across several servers and clients. Java can be used in several scenarios, independent of the system that it is used on. So let's look into what Java Development Kit means. All the Java applications and applets are developed using the Java Development Kit, that is JDK. Now, the JDK consists of the Java runtime environment, an interpreter, a compiler, an archiver, and a document generator, and a few more tools that go into developing a Java program. So now, let us have a look at the components of JDK. Java Runtime Environment, JRE, primarily is a part of JDK, and it can also be termed as Java RTE. The JDK provides the minimal amount of requirements needed to write and compile a Java program. JRE consists of the JVM, supporting files, and the core classes. The JVM is key to both JDK and the JRE because it is embedded into them. Now, whichever Java program is being run, the JVM is that component of Java that executes a program line by line, thus giving itself the work of an interpreter. We are now in a position to deep dive into the process with which JDK, JRE, and JVM work. Let's take a source file and save it with the extension .java. This file is compiled and converted into a set of bytecode which changes the file extension into .class. This is done specifically by the JDK. Now, here are the steps that follow. Class loader. It makes sure that all the necessary classes are loaded in the time of the execution of a program. Next, bytecode verifier, that is JVM. The bytecode verifier checks the code for errors or irregularities based on access rights on objects or implementation of pointers. It makes sure that the code fulfills the specifications of JVM and does not break the system integrity. And finally, interpreter, which is JVM. Now, while running the program, the interpreter loads, checks, and runs the code. The implementation is made by the JRE, which is the final process. The latest release is JDK 9 and it was released in October 2017. But it was in JDK 8 that a new feature called the Java Lambda expression was introduced that changed the face of Java. Now, Java Lambda expression is a kind of function which does not need any class to be created. It has been included in the latest version of JDK as it provides a clear, concise way to pass functions around. This also replaces earlier bulky anonymous classes and reduces code verbosity, that is, the length of the code. The syntax for the Lambda expression is this: argument list, arrow token, body. Now the syntax consists of three components, which are argument list. This can be empty or non-empty. Next, the arrow token. Now this is used to link argument to body. And finally, body. This contains the statement that works with the function. Let us now just see an example of using Lambda expression and contrasting it with how code would have been written with anonymous classes. This is the old method and this is the new method with Lambda expression. Just have a look at how Lambda expression syntax has been used over here. The JDK 9 has been released recently and it seems promising with respect to new features and abilities. Here are some of the features. The first one is Java Platform Module System. This module allows strong encapsulation and declare explicit dependencies. Next, JShell. With the help of JShell, one can directly start writing the code on the console and execute them. Improved Java Doc. Java docs have got the search right in the API documentation, and as an added bonus, the output is also compliant to HTML5. Next, Stream API. The Stream API, also introduced in Java 8, allows programmers to easily parallelize code for improved concurrency and introduces functional programming abilities to the language. The Stream API, in conjunction with Lambda expressions, also comes in handy while iterating, filtering, and extracting large amount of data. The release of multi-jar makes it possible for codes to be run on the newer versions of JDK to be released. So, to sum up, it can be said that Java or JDK is one of the giants amongst all the programming languages available in the market, given the fact that it's being widely being used in the industry. With the latest release of JDK version 9 and the interesting new features it brings along, it is pretty evident that Java is going to break newer grounds in the world of programming.
So what are objects? An object is an instance of a class. Let's have a look at an example. In this example, animal is a class and dog is its object. The object dog has states and behaviors. We can have dogs with different breeds, sizes, and colors. These are considered as the states of object dog. On behavior side, dog has behavior like barking, eating, and wagging tail. So an object has its own states and behaviors. Now let's look at an example using Java code. There are many platforms to run Java program. So for this video, I'll be using IntelliJ. So let's create a new project. Let's name it as project 1 and finish. There we go. We have a new project. We have a class with main and we have a main function. So the code that we write should always be written in the main function. So let's create a new class to understand how the object is used. Let's name it as student. We need variables so that we can access the variables of this class. So I'm going to use student ID with the integer type, student name, and student's age. There we go. Now we have these three variables that we can use. So let's go to our main program and start our coding. So we have a class named student. Now let's see how to create an object of a class. This is the syntax to create an object. Now the object here is S. I created an object S of class student. Now let's assign values to the variables. For this, we use the object S and use the dot operator, and we have options from which we can choose from that we declared in the class student. So for this, I'll use ID and give a value. Similarly, I'll give age and give a value. And finally, let's give a name. Now we'll print its value. Now we are going to run this program. Let's see what output we'll get. And there it is. We have name, that's Simplilearn, we have age, and we have ID. Now let us see an example how we can use multiple objects for a single class. So let's get started. Let's create a new project and I'm going to name it as vehicles. Because I'm going to use cars and bikes in this program, so I'm going to use vehicles as a combined form. And yes, here we have a class main and a function main. Now I need two classes for this program. So I'm going to create two classes. First I'm going to name it as bikes, and the second class I'm going to name it as cars. So let's create variables for these classes. So in cars, first I need string, name, and I need the cost of the car. So cost can be integer as well, because I'm going to use $sign in that. So I'm going to use string because of that. So same thing I'm going to do with bikes. Now that our classes are created, let's create objects for this class. So the process is same, but we are going to use different names for the object. First, the car class, and I'm going to name as car1. And yes, we have created the first object. Now to create the second object, similarly, I'm going to create 5 objects of the class cars. And I'm going to change the name for them. So I created 5 objects of the same class. So I'm going to create 5 objects of the bikes class as well. So bike one will be a bit longer. So I'm going to use B1 till B5.
and I'm going to name them to from B1 to B5. So now I'm going to assign values to the variables that I created in classes bike and cars. So first I'm going to go with cars and let's name it as Lamborghini. Similarly, car 2, Ferrari. So I'm going to use names of the cars that are very famous and costly so that anyone over the world can understand this. So let's name car 3. I'm going to name it as Bugatti. Similarly, car 4, Pagani, and car 5. Now I'm going to give names for bikes. I hope everyone will understand the names that I give. B4 and B5, the last one, Yamaha. Now let's assign the cost for bikes and cars as well. So the procedure is same. So let's do at 130,000. Same B2. So B1 goes for Harley Davidson, B2 for Ducati, B3 for Suzuki, B4 for Ecos, and B5 for Yamaha. I'm gonna assign values for these values accordingly. For Ducati, $232,000. For Suzuki, 200,000. 300,000. And the last one, Yamaha, 500,000. Now similarly, I'm going to assign values for car1.cost till car5.cost. $203,000 for Lambo. I think I can copy paste these as well. So let's copy paste. It will be a lot faster and easier to do. Car 2, car 3, car 4 and car 5. We don't need this. As per car 2, let's take it as 252,000 and let's make it as 3 million. As per this, let's keep it as 1,400,000 and lastly let's take it as 293. Now that we have assigned all the values for all this, now let's print it and get the value. I'm going to create a very simple program but a very user-friendly program. So it's going to be interesting for you guys. So we are going to ask the users what would they like, either bikes or cars. So we need to give them the options and our next program will be based on the options that the users select, not the options we give as the command. So let's do it. Let's give the options 1 bikes and 2 cars. I need to take the value that user gives. For this, I'm going to write this command. So I have not used scanner yet. So let's import scanner. And let's create an object for scanner. And yes, let's get back. So the data type of choice variable is integer. That's why I'm using next int. If the data type was string, then I would have used next line. So now that we have choice from the user, let's use this value. If the user chooses the first value, that means bikes. So the next thing we display is we have models and we are going to give 5 models for bikes to the user. Here I am giving options to the users so that they can choose easily from number 1 to 5. Now we can show these options to the users so that they can choose from one of these value. So let's use one more if statement so that we can find out whether they have this value or not. Before that, I'm gonna ask which one would you like to choose. To enter the choice, I'm gonna use one more variable. Let's say n. So I'm gonna store n. If n is equal to 1, that means Harley Davidson, then I'm gonna show the cost of Harley Davidson. This is the syntax to print the value for the cost or any of the variable that we use in class. What if the user says second or third or fourth or fifth? So for that we are going to use else if statements. If n is 2, that means Ducati. So we have to show the rate of Ducati or the cost of Ducati to the user. Now similarly, I'm going to do for n is equal to 3, n is equal to 4 and n is equal to 5. Now I'm going to do for n is equal to 4. And lastly, n is equal to 5. That is our last bike, Yamaha. What if the users put a number that is not between 1 to 5? So for that I'm going to use else statement and put a message that please enter the value from 1 and 5. So now we have code for the bikes, and the same thing, what if the user selects that he wants to find the car? So for that we have this, the choice is equal to 1. So the same thing we are going to do for choice is equal to 2. And the same thing we are going to tell to user that we have 5 models. The same names that I gave to variables, I'm going to give this to here. Second one Ferrari, third Bugatti, fourth Ecos, and the last one Porsche. Now we are going to ask the users their choice, that which number do they want to choose. Now we need one more value so that we can have it as a variable which can store the choice of the user. So for this I'm going to use C. Now if C is equal to 1, that means if the user wants to see the cost of Lamborghini, that he puts the choice as 1. So we're going to display this message, the cost of Lamborghini. And we are going to use else if loop to enter the next values for C from 1 to 5. If C is equal to 2, that means the user wants to know the rate of Ferrari, then we are going to show the cost of the Ferrari. Same thing if the user enters 3 as the choice. If user enters 4 as the choice, then we go for Ecos. And the last one, if user enters the choice as 5, then we have to display the cost of Porsche. Now what if the user enters none of the values from 1 to 5? Then we have to display a message showing that please enter the value between 1 to 5. Now remember the first choice that we wanted from user to enter either bikes or cars. So what if the user do not enter either 1 or 2? So for that we need one more else function to tell the user that either enter 1 or 2. And with this we have completed our code. So now let's run this program. For this we need to go to run and then run main. There's a shortcut for it, that is shift plus F10. So let's run the program. And yes, we have successfully executed the program. Let's test this program now. So enter your choice. I'm going to enter 1 And yeah, we have 5 models: Harley Davidson, Ducati, Suzuki, Pagani and Yamaha. So enter your choice. I'm gonna enter 1. And yeah, we have our result. The cost of Harley Davidson is $130,000. So with this, we have completed our code. And please feel free to type this code in your own computer and try out all the permutation and combinations that you can with this program. So with this, let's move on to classes and understand the classes and their concept. Then we'll have a new program on classes. Now let's see what is a class. A class is a blueprint from which objects are created. A class describes state or behavior of an object. In this example, dog is a class. The variables in this class are breed and color. The functions or methods of the class dog are barking, hungry, and sleeping. We use objects of a class to use variables and functions of the class. With this, let's understand classes with a simple Java code. Let's create a new project. Next, tick the box and let's name it as automobiles. Let the base package be student, and yes, we have a class main. Now let's create some classes to do code on. I'll create a new Java class as cars, and then I'll create one more class with the name bikes, and then one more class automobiles. So I'm gonna connect cars and bikes with automobiles so that we can use that program in main and see what can we do with the classes that we create. In automobiles, I need some variables. I'll take private, double, and let's say fuel. And then same thing, private, double, and then year. And let's take one more, private, string, and brand. Now let's have getters and setters for this. So these are used to get the value and set the value for the variables inside the class. There we go. We have the getters and setters for it. Now let's go to class cars. So public class cars extends automobiles. So in it, I'm gonna create one more class or a constructor. And I'm gonna print a message. Say a new car has been created. Car has been created. Now the same thing I'm gonna do with bikes. Let's go to bikes and I'm gonna use the same thing, extends automobiles. This is because I can inherit all the variables from the automobiles class. So I created a constructor and I'm gonna print a message. A new bike has been created. So I have created class, cars, bikes and automobiles. So let's go to main program. So this is where we should write our code. So I'm going to start with the code now. It's a very simple code. First I'm going to create the variables or the objects of the class with private bikes, bike. So one is car and one is bike. Both are objects for the classes. So I'm going to use these objects. Bikes, bike is equal to new bike. This is so that my object can function really well, and now I'm going to run it. It will take some time to run. And yes, there we go. Our program has executed and the things that I typed, a new car has been created, a new bike has been created, are done. Now let's try something else using the classes. So I'm going to bikes. So I'm going to create a new method or a new function, public void kick for bike. So I'm going to print message. The bike has been started with kick. Bike has been started with kick. Now the same thing I'm going to do with cars. Now how does a car start? With the key. So I'm going to make a function, public key, and inside it I'm going to print the same message, car has been started with key. Oh, I should write void there to give the return value as void. So let's print the message, car has been started with key rotation. Let's write that as well. So in the main program I'm going to use objects to use those functions, and let's see what changes they'll do to our program. Bike.kick and car.kick. Let's run this. And there we go. First we used to have this two messages, but now these two messages are also there as well, because we invoked those functions and methods that are there in class cars and bikes. So if I write bike.key or car.kick, this won't work. This is because key is not a method of bike or kick is not a method of car. So that's why I gave private static for the functions.
What is an abstract class? The answer is, abstraction is one of the keys to achieving an object-oriented programming approach in designing a software. Here, the programmer tries to hide the complicated implementation of the code which makes the software run smoothly. Most of the time, the user isn't interested to know how the code is being implemented. So, through abstraction, we can just hide it. To do so, we use an abstract class or sometimes an interface based on the requirement. So, abstract class in Java is considered as a template of methods and variables which are used in a program. Remember, abstract classes cannot be instantiated directly. Now moving ahead, we will next learn the important features of abstract classes. So the first one is template. The main reason programmers prefer to use abstract methods is because they act as a predefined template for any future specific class that you might use. Next, loose coupling is a procedure where an internal object gets the necessary method or a different object from the external world, that is, other than the current working project. The use of abstract classes makes this process possible. After that, we have the code reusability. Implementation of the abstract classes provides the developers with one of the greatest features that saves time, which is none other than the code reusability. Followed by code reusability, we have abstraction. As discussed earlier, data abstraction is the process of hiding certain details and showing only essential information to the user. Abstraction can be achieved with either abstract classes or interfaces. Last but not the least, dynamic method resolution. The abstract classes enable us with dynamic method resolution or the dynamic method dispatch process. The dynamic method resolution is a mechanism by which a call to an overridden method is resolved at runtime. This is how Java implements runtime polymorphism. When an overridden method is called by reference, Java determines which version of that method to execute based on the type of object it refers to. Now, these were the few important features of abstract classes. Next in the docket is the crucial rules to be followed to use abstract classes. Alright, let us go through the rules one by one as mentioned below. The first one is, the keyword abstract is mandatory to declare an abstract class. Followed by that, the next rule says that abstract classes cannot be instantiated directly. The third one is, an abstract class must have at least one abstract method. Next to that, we have another rule which says an abstract class includes final methods. Next, an abstract class may also include non-abstract methods. It's not mandatory that an abstract class should only include abstract methods. So the last rule says that an abstract class can include constructors and static methods. So these were some crucial rules to be followed to use abstract classes in Java. So far, we have discussed the definition of abstract classes, its features, and the rules to use abstract classes in Java. Now, we will learn how to achieve abstraction in Java. So basically, there are two different ways to achieve abstraction in Java. The first way is by using abstract classes, and the next one is by using an interface. Now, this brings us to our next topic, that is the syntax to be followed to use an abstract class and an abstract method. To declare an abstract class, we use the keyword called abstract. Followed by that, we use the keyword called class. Then after that, we declare the name of our class. The name of the class is up to the user's choice. For example, I have named my class as Simplilearn as shown here. followed by the abstract class, we have the abstract method. To declare an abstract method, we use the keyword called abstract. Then the return type of the method. As of now, I have used void. Then later we have the name of the method that is based on the user's choice. As you can see, I have used Simplilearn as the name of the method. So this was by using abstract class method. The next one is by using an interface method. Now, what exactly is an interface? So interface can be defined as a boundary between the method and the class implementing it. In Java, we use interface to achieve abstraction. In other words, we can also consider interface as a container which saves the signatures of the methods used in a program. Now we will move ahead and understand the syntax to use an interface to achieve abstraction in Java. To declare an interface, we use the keyword called interface. Followed by that, we declare the name of a class. The class name is up to the user's choice. For example, I have named my class as Simplilearn as shown below. As discussed earlier, interface acts just as a container that stores only the signatures of the method. We cannot have a complete method defined inside it. All we can do is just declare an interface. Now that we have a detailed explanation about the abstract class and the interface, let us look into some example programs based on abstract classes. Now we have successfully booted the Eclipse IDE. Now let's create a new project. So to create a new project, just click on Create a Project. And this should give you a dialog box wherein you have to select Java project. Click Next. Now let us give a name to our project. So Simplilearn will be the name of my project here. Now let me click on Finish to finish this process. As you can see, the project has been successfully created. And inside the project Simplilearn, we have the source file, and right-clicking the source file will give us a drop box where you can just select New, and inside New you can select a new package. Now let's name the package as Abstraction and click on Finish to create the package. Moving further, let's right-click on the package and select New, and from New select a class to create a new class. So the name of my class will be Employee. Let's click on Finish to create the class. Now we have our Employee class ready. Now let's right click on the package and select New, and inside that let us select another class. And the name of this particular class will be Person, which will act as our abstract class. So as you can see, we have declared this particular class with the keyword abstract, and the name of the class is Person. So our first example, which is based on employees, where we will have an abstract class called Person, and this Person class will be inherited by the Employee class and gets executed to generate employee details. Now let us try to execute this program and see the output. To execute the program, just right click on the package and go to the Run option and select the first one, that is Java Application. Now you can see we have the employee named Pavitra and the gender is female and the employee has logged in successfully. So these are the details which we were expecting to be presented on the output console. Now moving ahead, we shall execute our next example, which will be based on students. So here the class student is the abstract class, and three different student classes, namely Raju, Pranita and Punit, will inherit the student class and generate the output that displays their particular ranks. So you can see our abstract class, that is student, is being declared using the keyword abstract, and inside that we have an abstract method which is getRank. And these classes, that are Raju, Pranita and Punit, will inherit the abstract class student and display their ranks. Now let us try to execute this program and see the output. As you can see, the three classes have successfully inherited the abstract class and displayed their ranks on the output console. Now let us move ahead and try to execute one last example based on abstract classes. So the third and last example is based on interest rates provided by different banks. Here we have an abstract class named loan, and all the banks described in the program will inherit the loan abstract class to calculate the rate of interest on the loans provided by them. As you can see, we have the abstract class, that is loan, and inside that we have the abstract method which is interest. So we have the classes Andhra Bank, Bank of Baroda, IDBC Bank, State Bank of India, which are inheriting the abstract class called loan and the method interest to display their rates of interest. Now let us try to execute this program and see the output. As you can see, the program got successfully executed and the rate of interest for loans from different banks has been displayed in the output console. So with this, we have entered into our next topic, where we understand the differences between an abstract class and an interface. So the first difference between the both is the keyword. While we declare an interface, we use the keyword called interface. On the other hand, when we declare an abstract class, we use the keyword abstract. Followed by that, the second difference is when you use an interface, the subclasses basically implement an interface. While on the other hand, when you use abstract classes, the subclasses extend an abstract class and inherit the properties of the abstract class. Followed by that, the third difference is multiple interfaces can be implemented, but on the other hand, only one abstract class can be extended at one particular instance. And the final difference between the both is interface is capable to support multiple inheritance, whereas on the other hand, abstract classes are not capable to support multiple inheritances. Multiple inheritance is none other than the diamond problem, which is not supported in Java. Now that we have understood the differences between the both, let us understand the major advantages and disadvantages of using an abstract class. Now first, we will discuss the advantages. So the advantages of using an abstract class in Java are: the abstract classes are highly beneficial in writing shorter codes. The abstract classes avoid code duplication. They enable code reusability, which is a major advantage. And finally, the last advantage is changes to the internal code implementation can be done without affecting the classes. So these were few of the major advantages of using an abstract class. Now moving ahead, we shall discuss the disadvantages of using abstract classes. Few of the disadvantages of using an abstract class in Java are: abstraction is expensive, as sometimes you need to handle cases and situations which are not necessary. Followed by that, the second disadvantage is object relational impedance mismatch in the case of RDBMS, and the last disadvantage is object relational mapping in case of frameworks like Hibernate. So these are the few important disadvantages of using abstract classes in Java that you need to consider before using them into your project.
What is Java interface? An interface is a container that stores the signatures of the methods to be implemented in the code segment. It's really hard to define interface because it's the meta of meta. It's basically a control object. And so you see these in projects where whoever is in charge needs to have a very high level of control of what everybody else is doing. Do you have to have an interface when you're doing programming? No. But if you're in a large project, you probably want one as director, or if you're receiving it, you might get the interface which you're supposed to use in your programming. So when we talk about the need for interface in Java, it's a total abstraction, and it's only the methods. We're not talking about any variables or anything like that, just the methods. You can do multiple inheritance, so you can inherit from different interfaces, and you can do loose coupling. And when we talk about loose coupling, you can think of 100 programmers working on a huge software package. And they really don't know what the other programmers are doing. They can't meddle with it. They can't mess with it. They have like a nice direct place they can do, and they have the information they need in the interface. So we'll talk about the syntax of the Java interface. The interface, then you have your interface name, and then you declare your constant fields, declare your methods, default method. And really, to understand this, we just need to take a look at an example in Java interface. And we're going to do the Java interface defined area. Just kind of a fun little code. For this, I'm going to jump into Eclipse. And we'll go ahead and create a new package. There we go. And we'll call this interface. And we're going to go ahead and add in Java. It won't let you do just straight interface because that's a reserved word. We'll go ahead and create that. And then underneath our package interface Java, we want to go ahead and actually add in an interface. And so we go underneath here, new interface, and let's go ahead and call this one, we'll call it area, interface area, and finish. So now we have our package and we have our area, and this is just the same package we did with our polymorphism and inheritance. So now we have a package, and we've added the object of an interface. And note that the interface is always public. You never have a private interface because it's a meta file. So it's always going to be accessed by other people and by other classes. And as we're creating these methods, this works just like you would any other method. I could easily put integer, and then we have maybe integer side 1, integer side 2. So you can see how you can do, like for the setup, this is going to be just like you do the rest of your class and the rest of your methods. But we're going to keep it simple. And we're just going to do void square, and let's go ahead and do public void rectangle. We'll put a rectangle in there too. So now we have a basic interface, in this case for area. One of the cool things about interface is I can go in here to create another, let me go back into my interface Java, and we'll do another interface, and we'll call this area curves. I don't know, just making that up. So we have our area curves, and maybe in this one happens to be for a circle. So we have our curved areas. Let me just go back in here. And maybe we'll do not only a circle, but an oval. There we go. So now we have our circle, oval, or ellipse, depending on what you want to use on here. And I can go back to my area. And just like you can in classes, this extends area curves. So now I can also do the extends, or in the case of inheritance, same as in a class. Exactly the same. It just makes it easier if you have a hierarchy of stuff coming down in your interface. Now we'll go back in here to the package. Oops. We're going to go back here and create a class, and let's go ahead and do that in here under our interface, new class, and we'll go ahead and call it shape area. And so now we have our new class shape area. How the heck do we use our inheritance area in here? Well, we just go ahead and do implements area. And so once we do that, we now have area, which happens to extend area under curves. And let's go back in here to our shapes area, the class. And what I want you to notice in Eclipse is the shape area has an underlined red. And if I hover my mouse for it, it's kind of hard to see here a little bit. I'll give you some options there, which will say, bring in your implements. You're implementing area, but you didn't do anything with it. That is what interfaces are all about. It's about forcing someone to show an error here. Now in Eclipse, I have it set so it won't throw an error if I run the program, but it's going to tag it. So even if I compile it right now, let me just go ahead and run this, even though it doesn't do anything, it still has the shape area underlined. And then it comes up here and also puts a little exclamation point at the top when I actually do some actual coding in here. Let me go ahead and do that so you can see what that looks like. There we go. We'll put in our main and we'll initiate our instance of shape area. And we'll go ahead and run this. Doesn't actually do anything. It's going to compile all our different pieces on here. And you still see the shape area is got the red light underneath of it. When it pops up, it says, hey, you have some unimplemented methods. Make type shape area abstract, or different solutions on there. It's because we don't have the actual code. It's saying, hey, you were told to use what's in area and you're not using it. Again, this is all about being in control. And so we have in here, when we go back into area, oops, that's area curves. Let's go all the way to area. We have to have square and rectangle in there. And because this extends area curves, we also have to have circle and oval. And so when we put that in there, we have to do an override. Just so our package actually does something, let's go ahead and bring in the scanner utility. This is just capturing your keyboard. That's what that's for, the Java utility scanner. And then we're going to go ahead and do our override. Use the @ symbol, override. There we go. And then we go ahead and take a look at what we had in area. Well, in area we had square, so let's go ahead and grab the square. This, of course, is just being very lazy and not having to retype it. So we have our public void square, and then we wanted to do something in here. In this case, we want to go ahead and create a scanner for the keyboard, and we'll do a new scanner system in. And that's all that is we're going to do, we're creating an object so we can capture keyboard input and request information from people. And since this is a square, let's see, we're not going to get too caught up in the code here. Oops. There we go. And we'll go ahead and do geometry of a square and compile it and run it. It still lets me compile and run it. And you can see down here it actually says, hey, enter the length of the side of the square. We'll put in 5. And the area of the square is 25. So when we look at just this part, we have it accesses the square, prompts us for our input, does the math of the square, and is fully functional. But I want you to look up here. It still says, this still has an error. It still says, hey, you're missing the stuff in here. You don't have all the pieces you're supposed to have in here. So if we're missing the pieces in the implements of area, we need to go ahead and put those in. Now, we're not going to go through and do all the different areas and walk through each piece. But we're going to look at this. When I put in our rectangle, which is, we have the square and the rectangle, and then we had the circle and the oval, you can see that the error goes away. So I no longer have a shape area with an error on it. And if I run it, it of course will still compile. There we go. And if I come down here, forgot I got to put in something for the square. We could also, instead of square, just do whatever it is. You'll see that circle still functions, although it's just going to do a printout as opposed to what we had before, where it takes in all the information, computes the area. This is what implements is about. It's about taking all this stuff and pulling it in and forcing the programmer or the people in the team to use the different methods that they need for that particular class. And there's one more thing that we want to do, and I'm going to take this extends out here. And then we're going to go back to the shape area, and you're going to see it's going to give me another error on here, a slightly different error. And the reason is that I did overrides, but these don't exist, so they don't know what I'm overriding or what the setup is. And let's say instead of importing area, instead of having area inherit area curves, we could also just implement area and area curves. And then you'll see that the error then goes away when I run the compiler. There we go. And this should remind you of something we talked about in inheritance. Inheritance, we were discussing in classes how you have a diamond effect. You can't inherit from two separate classes. You can implement two separate interfaces. That means that if you have, you're the head of a project, you can now say, hey, this class needs these different pieces. So it's a very powerful tool, and it's one of the ways to force programmers to put in the modules they need and get around the diamond effect. Let's take a look at interface nesting in Java. Nested interface is a procedure declaring a new interface, either an existing interface or inside a class. And let's go back into here, a little play area. Let me just close these out real quick. And let's go ahead and add another package in, and we'll do new package. And we're going to call this, well, instead of inner interface, let's call it nested interface. There we go, our nested interface package. Finish. And once we're underneath this package, we want to go ahead and add in an interface. And we'll put a new interface in it. And we're going to call this, this is going to be a little confusing, interface outer. And then in our interface outer, we're going to go ahead and create an interface inner. Let me put that in this. So here's our interface outer, here's our interface inner, and our void inner method. And then let's go ahead and add in a class, new class, and we'll call this the nested, oops, and we'll call this the nested IF for interface. And let's go ahead and finish that. So here's our class. And in our class, we're going to go ahead and import inner interface.interface outer.interface enter. Whoops, forgot I changed the name to nested interface for the package. So we're going to import from our package nested interface, interface outer, interface inner. And that just means that we're going from here's our interface outer, and here's our interface inner. You can create a stack of interfaces so that when you send the package out, instead of sending out 50 different interfaces, you can send one interface out with all the sub-interfaces embedded in it. And you can see it highlighted there. The nested if still comes up with an error because we haven't done our override. And we'll go ahead and put in a public here. And we'll just do initiate our nested IF class. I guess nested if. There we go. So let's go ahead and initiate that. We're going to have our object equals a new nested if. And again, if we compile it, and we'll go ahead and run it, and I'll do the compilation here, you can see that it compiles fine. It's not going to give you any errors. But when you hover over here, it says, hey, you need to add unimplemented methods. And you left some stuff out of here that you were told you're going to include, which was this interface inner. And of course, we can simply do that. There we go, make it look a little nice. Do our override. And then once we have our override, we need to go ahead and create the method. So it's telling us we have to have that method in there, or we're going to get an error. And that was our inner method that we included. And then it's whatever we decide to do in here. Let's say we wanted to go ahead and we want to find the first 15 prime numbers. And our team in the back put together a little piece of code for that. It's always fun to throw something in interesting so you're not just looking at a print. I did something really cool here. That can get boring after a while. So we'll go ahead and do integer. We're going to iterate equals 0, number equals 0, x equals 1, y equals 1. And then while number is less than 15, y equals 1, and we iteration equals 0. So forth. You can see here we're doing what is, if you divide, is there any leftover? If there is no leftover, then that means it's divisible. That's not a prime. Otherwise, if the iteration equals 2, system out is going to print the number, and then we're going to add another number to it and just keep looping through. So you can see right here, this is just a simple set of code, but there goes my error. My error is gone. That's what's important. We have our inner method. There's no more error on here because we've now included it. That came from our nested setup on here. And of course, if we're going to put a code in there to count the prime numbers, we should probably go ahead and do our object method and run that. There we go. And sure enough, we have our 2, 3, 5, 7, 11. There's our list of prime numbers. So just to kind of hammer it home, what is the difference between interface versus class? Interface, keyword used is interface. Keyword used for class is class. Interface does not include instructors, where class has its constructors in there. Interface stores only methods, only the method signature, where class has the storage of the actual definition. So just the signature versus a full method in there. There's no access specifiers in the interface, where of course there is access specifiers are needed in class. No data members, includes data members in class. No static members, includes static members in class. So think of the interface as being just instructions. They're instructions on methods. That's all they are. They say, hey, you have to do this as a programmer because your head of your department said this is what needs to be in here. Or maybe you have a very complicated code with a lot of the same pieces, and it says, hey, don't forget these pieces because we're going to give you an error if you don't. What are the advantages of interface? Well, using interfaces has increased the simplicity in programming. Some of the advantages are complete abstraction is achieved with no ambiguity. And that is very key. That is a whole thing. It's saying, hey, we need these in this class. You have loose coupling between the data and methods. So now your team can have what they need without having to go through and understand what the whole picture is. They can build on small pieces and really focus on it. It resolves the diamond problem. Remember from classes, you can only inherit from one class. Now I can come in and say, hey, these procedures, these methods all need to be in here, and I can have as many methods as I want in there. It resolves the complexities in defining dependencies. So again, you have this whole archive, and it's almost like telling a story. This is what we're building. This is what it looks like. Disadvantages of interface. Using interfaces has some disadvantages. Obviously, the first one I look at is if you're working on a really small project, you've added a whole layer of complexity to it. So when you're working on smaller projects, you almost never see interfaces. The interface in the real world project is used either extensively or not at all. And so you will see, instead of an interface, they'll just send you a list of what you have to have in there. That's pretty common, but with the interface, it forces the programmer, so when it goes back up the chain and everything needs to be put together. And so it gets a little confusing because some people are like, oh, I got to use an interface, or I don't. And the use of the interface can reduce the execution speed. You're adding a whole nother layer there where it has to look that information up. And so if you're doing like a huge multi-task process and you're spreading it across multiple processors, and so now you have hundreds of these classes that are pulling in hundreds of these interfaces, that's going to add a little ding to your speed, and it might not be something you want to do there for a process like that, which is very different where if you're writing a game and each player and each module for their character, which has certain things they have to do, which is move left, move right, move up, down, and then they have all the new games always have a special thing they can do that has to be embedded into that class.
Let's see the definition of encapsulation. Encapsulation is like a capsule. The whole code and data is bounded together into a single unit. Another way to think about encapsulation is, it is a protective shield that prevents the data from being accessed by the code outside this shield. As you can see, variables and methods are defined inside one class like a capsule. Now the question is, why do we need encapsulation? The main reasons are, first, better control of class attributes and methods. Second, class attributes can be made read-only or write-only. Third, it makes Java code very flexible. This means the programmer can change one part of the code without affecting other parts. Apart from these, encapsulation is mainly used to protect data and increase security of the code. As you can see, to protect the data, variables must be private and they can only be accessed through methods. Now, let's see Java code for encapsulation to understand the concept better. So now let's create a new project. Next, and I'm gonna name it as Encap1. So here we have our main class. We can write the code here. So before writing the code, let me create a new class. Right click, new Java class, and I'm gonna name it as employee. So in this program, we are going to use a classic example of employee using employee name, ID and salary. So in this class, let me create variables. First string name, then integer ID, and then int salary. So I can easily use these variables in our main program by creating object of the class. So let me just create the object. Employee is equal to new employee. Now I can use e.id, name or salary, anything I need to. But this program is about encapsulation. So this is an easy program we can do, but in order to secure our programs when we have a large number of program and large number of lines in a program, so we need encapsulation at that time so that data can be secured. So for that, I'm gonna name it as private. Now all three variables are private, so I can't use them. See, we can't see them anymore. If I write ID, we'll get a red color here. So if we go on it, we can see ID has private access. So that means we can't use it directly. Because of this, we need getters and setters that are normally methods that are used for these. So right click, generate, and here you can see getters and setters. So just select all of them and OK. So now we can use these methods instead of direct using the variables. So we can get in the starting, then set, then get, and again set. So likewise it goes like this. So now we have set here. So if I want to declare variable and if I want to put some value inside my variable, so how can I do that? Here you can see get ID or get salary. So if I go for get ID, if I go for e.setID and I set it as 6, so this shows no error. This means we can use methods to access variables. So let's complete our program now. First, I'm gonna set everything. And lastly, e.setSalary. Let's get it as 30,000. Maybe in dollars or maybe in rupees. Let's just set it as 30,000 for now. So how I'm gonna print it? For this, I'm gonna go to a print statement and then name and not set name, but this time I'm gonna go with get name. Get name is to return the value of the name that I have given. So in this case, that's Simplilearn. And next will be ID and e.getID. And lastly, salary, e.getSalary. So this is a simple program that is used to define encapsulation. If we don't use private variables, that becomes a normal program. So when we use encapsulation, we are going to use private every time whenever we declare variables so that it's secure and no one can access the variables directly. So now let's run the program. And there we go, we have our result. We have executed the program successfully, and as you can see, name Simplilearn, ID is 6 and salary is 30,000. So I hope you understood the concept of encapsulation. So the main concept of encapsulation is all the variables can be accessed through methods. So for this we use getters and setters that are inbuilt functions for IntelliJ or NetBeans or Eclipse.
What is inheritance? There are two other key terms which are not going to be in this agenda, but you should also, when you get to them, make sure you bundle them together as you're understanding these structures. And that's the abstract class and the polymorphism. So what is inheritance? Inheritance is an act through which a new class gets created by acquiring the variables and methods defined in the previous parent class. So when we look at what is inheritance, we can take an example of, say, food. We have veggies, noodles, fruits, where food is the parent, and your veggies, your noodles, and fruits are all subclasses of that. They're all kind of children of food. Why do we need inheritance? We implement inheritance for a multiple of reasons, like creating a possibility to add or remove features, to reduce the code length as we reuse the code, more comfortable to develop and maintain the project. And so if we start looking at, let's say we have a cell phone. We make calls, we have our SMS texting, our communication. On our phone we have our media. We also had a browser on there, because now we have a smartphone. And we look at that, we have our phone set up, and then we have our full smartphone, media, call, SMS, and browser. And we start to kind of link these. Instead of making them separate, we can have the call and the text, and then we can have them inherit. We can actually create a media that inherits their qualities. So now you can text your media. Now you can use the browser as part of your call scenario. And I would even add one more example in here, and that is that all programming languages that are object-based are built on inheritance. Java, Python, C++. So this concept of building an object, and then that object then is inherited by everything underneath of it, is important to understand, even in these even as we're looking at more specific cases. So we'll take a look at the components of inheritance. And the most important two components in inheritance, the two major components that are mentioned, are parent class, or the superclass, and the child class, or the subclass. And to see this, let's go ahead and jump into Eclipse and take a look at what the actual code looks like. So the first thing I want to do is go ahead and add in a new package. And we're going to go ahead and call this package inheritance, because that's what we're working with. Oops. Give me a default Java tutorial in there. Inheritance, finish. And I started off with the Java tutorial as just a, went in and created a new project and made sure it was Java based. So we have our package inheritance right here. We're going to go ahead and add in a new class. And we'll go ahead and call this class machine. Now, one of the standards when you're creating classes is to capitalize the first letter, so always remember to do that. In some places, people like to have the whole word capitalized. It really depends on who you're working with. But it is kind of, if it starts with a capital letter, it's probably a class. And so once we have our inheritance, we have our public class machine. Let's go ahead and give it a little bit underneath there to do something. And we'll start with protected string brand. And so whatever machine we're working with, these particular machines are going to be, we'll call them, it'll be a Samsung. Free, they get some free marketing right there for Samsung. So Samsung machines. And then we want it to do something, so let's go ahead and put a procedure in there. And we'll make it public, void, because it's not going to return anything. And we'll call this wash. I guess they're all wash machines. There we go. There's our brackets. A little trouble finding the bracket on there. And let's just have it, during this, we'll just have it do a quick print line. And we'll say initiating cycle. There. And then, of course, our semicolon on the end. All right, so now we have a public class machine. And we're going to get into where we start working with the actual inheritance. You can create an object with this machine. We haven't done anything special to it. It's like any other class you might create in the Java language. And we've added in public void wash, a procedure with no return. That's what the void means. And it's going to print out. And so let's go ahead and create another class in here. New class. And this one's going to be washing machine. Washing machine. And we'll go ahead and hit finish on here. And we come into our washing machine. It's opened up a nice new tab for us. And we might have a private string model name. And we'll change this to model type. Model type equals, so the type of machine is a top load washing machine. So we have a Samsung as the main type of machines we're looking at, and we have top loader or top loading washing machine. And then we're going to add up here extends machine. And so this is the key code we're going to look for, because we want this to have the properties of the machine. So this comes in and says whatever's in machine, we now also have in our washing machine. And then, of course, if we're going to do all this, we need to actually be able to run it. And if we're going to do that, we want to go ahead and add in the public static void main, reserved keywords there. And this is just your standard main startup. You have your string of arguments. There we go. And of course our bracket. And then in here, we're going to take and create a washing machine object. And so here's our wash machine. It's of course the type washing machine. And it's going to equal a new washing machine. So we're initiating a new object in here. There we go. And then we want to do something. And if we're going to have it do something, we want it to go ahead. Let's see what happens when we have wash. Remember our keyword up there was washing machine dot wash. And where did that come from? Well, if we go back into machine, here it is, public void wash. There's the procedure, and it's coming into the washing machine, and this is inherited. That way we don't have to retype that every time we have a washing machine. This could be washing machine. Maybe the next one is, I don't know, a different kind of washing machines. I'm not an expert on washing machines. But we have it do a wash, and then specific to the washing machine in here, we also had the type. And so we can come back up here, or brand. So we can come up down here, we can go system dot print line wash machine dot brand plus put a little dash in there, plus, and then we're going to go ahead and we have our wash machine dot model type. That model type we put in there. So the brand, where does the brand come from? The brand's coming from our machine. We have our protected string, which is going to be Samsung. And then we have our washing machine, which has the model type, which is a top load machine. And if we go ahead and run this, after, of course, we make sure we have that semicolon in on the end there. We come up there, we'll see initiating cycle. Initiating cycle is printed out from machine, and then the Samsung top load washing machine is the second printout line here. And so when we have our wash printout here also, the wash machine wash is initiating cycle, and then we have, that's where that printout comes from. We can go back up here to machine. You can see right here initiating cycle. And then we flip back over to the washing machine, and we print out washmachine.brand, which is the machine class, and then washmachine.modelType, which is underneath the washing machine. So let's go over all that. Let's take a look and see what we're talking about here. So we saw in the code the extends keyword. The term extends is a predefined keyword in Java that allows you to create a new child class by deriving the variables and methods from the parent class to reduce code length and improve the performance. And we see that right up here in our public class washing machine extends machine. So the next key thing to talk about is access modifiers. And I kind of breezed over them when I put together the code, but we'll dig in there a little deeper. When we talk about access modifiers, there's 4 different words you really need to know, and that's default, public, protected, and private. And I'm going to tell you right now, default equals public. So what is default? Default access modifier is set implicitly whenever you declare a class without a specific access modifier. By default, the access of a class or method, when declared without a specific access modifier, becomes available to any other method or class within the same package. And in Java, the default is public. So public, a certain class can be declared as public by using the keyword public. Any class or method, when declared as public, becomes available to any class or method declared in the same package. But if a different method or class needs it, it should be imported. And then we have protected. A certain class is declared protected by using the keyword protected. This provides access to the methods and variables of the protected class only to the rightful subclasses and protects the data from any other classes which are not related. And then private. A certain class is declared protected by using the keyword private. This provides the ultimate protection to the data members and the methods of the private class. This procedure is implemented by class to encapsulate the method and members. So we'll take a little, we're actually going to do a different example in here, but I do like this underneath the washing machine. You can see right here we have put in private, a private string. What this means is that only washing machine can access that private string. Where if you have protected, the children can access it. So a protected screen, if you're underneath a machine up here, we have protected, so that when I create the washing machine and extend machine, I can still access it. But if I create a subclass of washing machine and I mark it as private, that subclass is not going to be able to access it. And so it has to do with what layers of accessing. Think of this as a big team project. You create something, do you really want that to cascade down to the next class? Or who do you want to have access to that? Let's go a little deeper to really bring this home, because it's really important to understand this terminology. Let's go ahead and start a new class here, and we're just going to call this particular class summation. And go ahead and create that, finish. And so our summation class, it's going to be pretty simple in here. We'll go ahead and do public. So anybody can access it. Just remember, here's our public on there. And then we'll just do a integer, because that's what it's going to return as an integer. We're going to call it add, and we're going to put integer x comma integer y. And then we'll just return x plus y. So real simple. We're just adding 2 numbers. Here's our 2 inputs. They both have to be integers. And we're going to return an integer, and it'll be the summation of the 2. So real simple class right there. And if we're going to have a summation, then let's go ahead and create a new class, and we'll call this one child. And in our new child class, we're going to go ahead and keep this simple, and we're just going to have our public static main. We're going to have our summation a equals new summation, and then system out print line a dot add 100 plus 200. Pretty straightforward. Everything's public in here. Oops, okay. There's our running, and we see that the answer is 300. So this is public. If you remember correctly, we're talking about public. And so when we use the public keyword, any class or method when declared as public becomes available to any class or method declared in the same package. But if a different method or class needs it, it should be imported. So here we go. That's our public setup. It's just open to everybody. Well, everybody that's under the package inheritance. So it's whoever's using that package can now use this particular child. And let's go ahead and add a new class in. And this time we're going to do a parent class. I'll just put that right in there. And we come in with our parent class. You can see right here the parent class itself is public. But what we want to do underneath the parent class is we want to create a protected void, because we're not returning anything, and print. So we're going to do the print there. And this protected print, let's go and put our brackets in there. And we'll do just a simple print line hello world. And once we have that print hello world, we want to go ahead and add a child class to this. And let's see, we had the child class when I took it out a second ago. So we'll go ahead and put that back in. Here's our child class. And for this child class, we want it to go ahead and extend the parent. So inheritance, there's our extend on there. Oops, let me retype that. All right, extends parent. So now the child class is part of the parent class. And we'll go ahead and put our main in there so that it will run it and execute it. And we'll create our child x equals new child class. So we'll go ahead and assign our variable x and initiate it. And then we'll do just the print and see what happens here. So here's our print statement. And we'll go ahead and run this and compile our child on there. And when it comes in there, you see it says print hello world. And so the parent has marked this as protected. So it's protected from objects that are not inheriting it, but the child can still access that information and print it on there. So here's protected. This provides access to methods and variables of the protected class only to the rightful subclasses and protects the data from any other classes which are not related. In a lot of programming, that's usually where you end up, is doing a lot of stuff that is underneath your parent that is protected. You either make them public or protected. A lot of people are sloppy and just make them public, but most of the stuff you want to make sure it's protected. And then we finally have our private, and I'm going to go back here to our child, and we're going to run this. And it's going to come up and say proceed with launch, errors in setup, and then it's going to give us an exception thread main. Compilation error, the method print from the type parent is not visible. And that's because unless you actually initiate the parent, you're not going to see this code because it's private. It's only private to the public, to the parent class. So even if I extend it in child, it will not be available. And that again protects it. That means it's something that you don't want to inherit and cascade down, because maybe it is a piece of code that is going to be changed, and so you don't want all the children to crash every time you make a change to it. So with private, this provides the ultimate protection to the data members in the methods of the private class. This procedure is implemented by class to encapsulate the methods and members. So very important. We have private, and we have protected, and we have public. The more access you want other pieces of the software code to have and other programmers to have, the more public you want to make it. And of course, the default is public. Now, one of the common workarounds for this, because you're going to have protected data, but you still want it to be used by the subclasses, is to create what they call like a get or a, and we'll do it up here. We'll go ahead and do a private integer x equals 5. And then instead of, on your inheritance, instead of having it call it from the child, we might have a get thing, or a get thing. We might have a public, it's going to return an integer, and we might have it say get x. And this simply just return x. And what this means is that when we have something simple like this where it just does a return x, I can go back into my child here, and instead of print x, we'll do x dot get x. And we'll go ahead and print this out, or yeah, something simple with that. We'll go ahead and do a system print line on this. And when we run this, You'll see it come up, it's going to recompile, and we get our 5. What's happening here is now I've created underneath the parent private information. You don't know what's going on with it, it's protected. You might have a procedure that's protected. In this case we had the print procedure, and then we access it from the public. And this could have easily have been, instead of, maybe we'll just call it public void public print. Kind of a goofy way of doing the code. There we go. And then it could go in here and access our print. And so we can actually still access this print variable up here by wrapping it in kind of a get or a public function. This allows us to protect whatever code is going on in the parent class, so it can't be messed up, it can't be accessed indirectly, it has to go through the right processes. And so when we get to the child on here, the child can then still has the public processes, but all the other information is protected and is private. It's really important to remember that private right there. This brings us to super keyword. And when we talk about the super keyword eliminates the confusion between parent class method and subclass method. Super keyword is implemented to access a method or constructor that is defined in the parent class. So back in Eclipse, we'll go under parent, and we'll take this, we're going to take the private out of there, so now we have an integer 5. And we'll go ahead and just remove the print because we're not going to do that in the parent. Oops, and the public. There we go. And so let's create a parent that just has one piece of information. It has an integer x equals 5. And then we're going to go to the child, and let's go ahead and add in here integer x equals 10. And these are, by default, they're public. We haven't set anything on here telling it what it is. And so what I'd like to do is we'd like to go ahead and create a, oops, one more thing, there we go. Create a procedure here, and we'll just call this void capital print. And it's just going to be a system out print line. And this is what I want you to notice is we're going to print out x and super x. So we have the child class x and we have the parent class super x. And if we come down here and we do x dot print, don't forget my semicolon, add a couple spaces in here to make it look nicer when we print it. And we'll go ahead and run this. And you can see that the child class prints 10 and the parent class is 5. And so this way you can actually store different information depending on what it is you're working on and what you're doing. And that's where this super comes in. You can see right here where the super underneath the class and the print module. Now you can't just put it in down here under print. And we can explore what that looks like. If I just take this and I go ahead and highlight it. And let's say I wanted to just, instead of doing xprint, it's going to come up right here. And right off the bat, you see the super.x. I can do x.super.x, and it's still going to give me an error right here. It has to be underneath a procedure in the actual class and not under the main. This brings us to types of inheritance. And there's 4 main types. We have single inheritance, which we've already pretty much looked at, but we'll go back over. We have multi-level inheritance. We have hierarchical inheritance and hybrid inheritance. Let's go ahead and just start with the single inheritance. Single inheritance consists of one parent class and one child class. Here, child class inherits parent class methods and data members. And let's go ahead and create a new class up here, just to change it up and keep it interesting. New class. And we'll call this one student. And under the student, we'll have a simple setup. We'll just do an enrolled, and it'll say enrolled in Simplilearn. There we go. So there's our class student. And then we'll create another class. We'll do it as a, because we have our student, our base student. And then we'll call this one new class. And we'll call this one computers. There we go. So he's enrolled, finish. And for computers, let's go ahead and put in a print line here. And we'll put down studying computers. And we want to go ahead and do the extends student. So it's a student studying computers, subclass computers. And this would all look familiar because we've been doing this for, a lot of the other setups. This is your basic inheritance. And we'll change that from enrolled to studies. And then let's go ahead and put a main in here so we can actually run it. And we have our P enrolled, which comes from our parent class, and our P studies, which comes from the child, or the one that inheritance it, the extends for student. And let's go ahead and run that. There we go, run. And you can say enrolled in Simplilearn studying computers. And then we can go on to the next setup. And this is where we look at multi-level inheritance. It is also a parent-child inheritance relation, but the difference is the child class is inherited by another child class. This is the basic structure of most programming languages right here. You have an object, you have all the different things under the object, and it gets all the way down to whether it's an array you're working with, whether even a class is a subchild that goes all the way up to the object. And we can simply do that in our code in Eclipse. And we'll just go ahead and add a new class in there. We'll call this one Java. There we go. Oops, Java. And under Java, we want to go ahead and create some of the similar stuff. And then I want to go back to my student. I took out the main and student just because I don't want it to run the main in there. And in here, we're going to have system out. We're going to have, instead of studying computers, focus on Java, which is what we're doing right now. And maybe we'll call this classroom. And then we can come down here and we have our P equals new computers. Well, instead of new computers, we want our Java, and it's going to be a Java object. And we need to put our extends in up here. Extends, in this case we came from computers. So there's our initial thing, and then we have our last print in here. And of course, if we run this now, we'll see that it should, if I did everything correctly, come up and say enrolled in Simplilearn, studying computers, focus on Java. And we have the enrolled, which is the parent to computers. And then we have under computers, well, we have student, then computers, and then Java. And so each one of these classes just cascades all the way down. And this is your multi-level from your class A to class B to class C. And if you can have multi-level inheritance, we can also have a hierarchical inheritance where your parent-child relationship, the only difference is here multiple child classes inherit from one parent class. And that is pretty, we'll do another class here. If you remember correctly, we had student, computers, maybe from student we'll have, instead of computers, we'll have project management. Project management. So you're studying your IDLE and all your other classes in there for Cascade and for doing agile programming. And in here we can do that. And it's just the same as we did before. We just have a second child coming in from here. And so this would go ahead and extends student. And of course, whatever subcategory you have one in here for running this. And so for here, we'd have like our void studies. In this case, instead of studying computers, we're studying project management. Project management, one of the other wonderful classes that is taught from the Simplilearn team. And we'll go and run that, and you can see right here we have computers. Oops, of course, instead of computers, I meant to do project management. There we go. And we have to also initiate it as a new. And then when we run here, we can see this. We're enrolled in Simplilearn, and we're studying project management. And then finally there is the hybrid. The name itself explains it to us. The hybrid inheritance can be a combination of any of the 3 types of inheritance supported in Java. And so maybe we already saw that because we have our A and our B. If we flip back on over to our Eclipse, we have our student. Our student now has a computers, project management. So there's our hierarchical, and then they're mixed because we also have the Java, which is an extension of the computer. And so we have multiple layers there. So one of the issues that comes up with inheritance in classes is what they call the diamond problem. And in the diamond problem, the Java programming language does not support multiple inheritance, as it ends up with serious ambiguity. And that is where we have D, which inherits from both B and C, which might both inherit from A. This is the diamond factor because as you start tracking your supers going up, which one are you actually looking at, B or C or A? And that's why they call this the diamond problem. It comes up more than you would think. You get very complicated structures and you realize, oh, I need to have both sets of instructions come down to whatever I'm working on. And you can see where that can become a problem. Let us take a look at is a relation and has a relation. Now these, I mean, they're vocabulary, but they're more of a concept, understanding how things fit together. And so when we talk about is a relation, when a class inherits methods and members from a different class, then the relationship is said to be is a relation. Examples, orange is a fruit. And let's just jump back on over here and we'll make a new class. And we'll call this class customer. So we're going to have our customers. Oops. There we go, if I can remember how to type. So we have a class customer. And I've gone ahead and our team in the back went ahead and prepped this for us. Let's just take a quick look though. We got public string name, so it's accessed publicly. If you leave this out, it'll automatically be public because that's the default. And then we have our customer and the string, which is a name, and a string is a city. And then when you do a customer and you send it the name and the city, it will do this name equals name and this city equals city. We could have easily done this private. We have a call into it to create it. So it wouldn't really matter too much whether we did it private or public. I would actually be more likely to do it private. And for this example, we'll go ahead and create another class and we'll call this store. We'll have our store class. So we have customers and we have a store. And then we'll go ahead and set up in here. And this time we did do a private. We're going to create a list of customers, and then the store list coming down, and then this customers, and public list customers. A quick look at this is we did make this one private, which is nice because now it can't be accessed externally except from store. And then store has the public list customers. So we can send it a list of customers and then it go ahead and returns the customers from that list. And then when we add it to the store, it sets the customers in the store. This.customers equals customers. One of the reasons we have the error lines in here is I haven't compiled it, so it doesn't see the customers are part of our package. And we'll get to that in just a moment here. And then let's go ahead and create another class. We'll call this is a relation, since that's what we're working on. And here's our is a relation setup. And we're just going to put this as the main, so you have your main in there. And then we went ahead and prepared a series of customers. And we'll just call it customer C1 equals a new customer, customer C2 equals a new customer. And we're just creating a list here. That's all we're doing. And if we're going to have a list, then we need to go ahead and create a list of customers. And we'll just do that with a simple list setup. And then we got to add those customers into the list. So let's go ahead and do that. So breaking this down, we have customer 1, which is Raju, Bangalore, Shiva, Hyderabad, Sachin, Mumbai, and so on. And then we just created a list of customers, a new array of lists, and then we add in each of those customers. So now we have a nice list of all our different customers in here. And then we want to go ahead and create our store. And we'll put in store, and it'll be a Fruit Smoothies franchise. I put down Fruit Smoothies French. Maybe that's not a good abbreviation because you might think it's a French instead of franchise. But it'll be a new store. And then we have our new store, which is, in this case, we're going to put in that new store customers. And if you remember, we went back here into store. Let me just flip back on over there. It's going to take that list of customers and put that into this customer. So now the private list is going to equal that list of customers. And then of course we can come in here and we do public list, it's going to return that list of customers. So we have public assets here, and this store, you can add public at the beginning. We'll go ahead and do that just to make it clear. Is it public is what's going to run on there. And let's go back into our is a relation. And flip back to store. I'm going to go ahead and just change this to customer list. So here's our list, customer list, and it's going to return the customers from this selection, from our private variable. So we come into here, we can come down here and we'll go ahead and put that in there. We'll do a loop on this. We'll have a list customer, and we're going to create a list of our customers from our Fruit Smoothies franchise, and we'll get the customer list from there. And then for a customer in the for customer CST in customer, we're going to go ahead and just print that name out there. Now at this point, if you have an error showing up here under list and also underneath array list, depending on how you did your install, you might have to go ahead and import those, your array list, from your Java utility. Not a big deal. And then once we go ahead and we have this all set up, you'll see here the compiler goes through, and then we have the name of the customer, city, and then it just lists the customers going down here. So when we talk about our relationship of our Fruit Smoothies franchise and customers, the customers, they are a relationship directly to the French Smoothies franchise. Now the second idea is it has a relation, and let's go ahead and take a look at that and see how that differs. And we'll go ahead and create a let's see, we had customers, so let's do and we'll call this one we're doing with smoothies, so we'll have flavors. Or favorite. We'll do favorite flavors. Favorite flavors for a class. Very strange class. And let's see, in favorite flavors, we'll go ahead and give it a couple things to look at. We'll have a private string and a name. And then we'll have a public string get flavor. There we go, and that's just going to return, we'll just have that return the name of the flavor. There we go. And then we want to go ahead and create one more class, and this class we'll call has a relation. And I'm hoping you're guessing where we're going with this. Let's go ahead and put some code in here to make it work. And let's go back to our favorite flavors and put in a constructor so that we can load the flavors, and then return this name so we can return the flavors. We'll go back into has a relation. And let's just create a customer. We'll call it cust. Our new customer is Toby Marshall from Mumbai. And our favorite flavors are strawberry, banana, and peanut butter. Don't know, it's a strange concoction. And then we run a print line. We're going to print the customer name from customers and the flavors get flavor. And so when we're looking at this, what I want you to be aware of is that neither the flavors nor the customer are in the same class. They're not. It's not an actual relationship, but they have a relationship because we have Toby who happens to like strawberry and peanut butter. And if you remember, just a quick note, we were looking at the diamond problem. You can create a class that then has these two subclasses in. And that's how you go around the diamond problem, is you don't inherit, but you create classes inside the class you're working with. What is polymorphism? According to chemistry, the term polymorphism can be defined as the ability of any element or compound to exist in multiple crystalline forms. This is called polymorphism. For example, if you have the carbon atom, it can come out in different forms in coal, graphite, and diamond. What is polymorphism in Java? Similarly, in the terms of Java programming language, polymorphism is defined as the ability of any object in a class to perform a particular task in multiple methods. This is known as polymorphism in Java. We're going to open up our Eclipse editor, and we're going to do some animal sounds with cows, cats, and dogs, just kind of a fun, almost kids-like example of polymorphism. And you can see I already have my inheritance in here. Let's go ahead and create a new package, and we'll call this polymorphism, just to keep it simple. And once we have our polymorphism in there, we're going to go ahead and add a class in. And if you were doing an abstract class, we can label it as abstract because we're not going to directly access it. And we'll call it animal sounds. Maybe we will. We'll see how we load the program up. But we'll call this animal sounds. And let's create a public, it's not going to return anything, but we'll call it sound on here. And we just want to go ahead and have it do a system out print. And with our system out print line, we'll just have it say animals make different sounds. There we go. So yeah, it's really simple and straightforward. We're just going to have it print something out. And if we're going to do that, let's go ahead and just, good thing I didn't make it abstract. Let's go ahead and just test it out and see what it looks like. And we'll do, we'll call it animal main. Animal main. And in here, let's go ahead and test out what we just put together. We'll do our static void main, so it's going to run on here. And we'll create our animal sounds. We'll call it animal, because we don't know what kind of animal this is. We'll call it new animal sounds. And we'll just take that animal, and I like to put it in capitalized, but usually we like to do this lowercase. There we go. And we'll just have our animal dot sound end. And let's go ahead and run this and see what comes out. We can see here animals make different sounds. Okay, that's not too exciting. So let's jump in there and let's say we have, in this case, we're going to add in a couple of different animals. We'll add in a, let's start with a cow. Yeah, why not a cow? So we'll have our cow in here. We'll go ahead and click OK. And now we have our cow class. But a cow doesn't just, it makes different noises, but it actually makes a very clear noise. So we'll go ahead and give the cow a sound. And we'll have the cow say moo moo. And the cow is going to extend. There's our, and we'll put in our extends animal sounds. And then I want to go back here to our animal main. And now we have a class cow. So in our animal main, we want to do cow equals new cow. And once we've created the new cow, we also need to go ahead and have the cow sounds. There we go. And we run this. You can see it comes out here and it says the cow says moo moo. So if we go back to cow, we're just going to do this real quick. And let's say we just take this out of here, the public void sound. And then we're going to go into our animal main and run that. Recompiles. Animals make different sounds because it doesn't know what sound a cow makes. So this is really central to polymorphism, is we're taking something going on in the in one setup that we've brought in and extended from our animal sounds, and we've changed it to the cow says moo moo. And we can also add in multiple animals in here. We'll go ahead and just add in one more animal. We'll call this one, we'll do a dog, why not? So here comes in our dog. And of course we want the dog to actually say something. And we'll have the dog go bow wow. And then we'll go back to our animal main, and we have to create a dog. And we'll say cow. Simply dog, dog. Uppercase for the class, lowercase for the actual object. And then of course we need the dog to make a sound. So we'll go down here and go dog dot sound. And when we run this, as you expect, it's going to compile it. There we go. Animals make different sounds. The cow says moo moo. The dog says bow wow. Characteristics of polymorphism. The functionality of a method behaves differently in different situations. The behavior of a method is dependent on the data. Polymorphism is mainly used to implement inheritance. As we saw, we did the extends with the animal sounds. Polymorphism is mainly used to implement inheritance. It allows same name for a member of method in a class with different types, which we'll cover briefly in a minute. Polymorphism supports implicit type conversion. Types of polymorphism. There are basically two types of polymorphism that can be occurred in Java programming language. They are mentioned as follows: compile time polymorphism, runtime polymorphism. Compile time polymorphism gets executed during the compilation stage. Here the overloading method gets resolved in compilation stage. So when you saw me run those in Eclipse and I went through the compile time, that's looking at all the different changes we made to those classes. That's what we're talking about here, is during compile time. In method overloading, in Java, the process of method overloading is achieved when a class has two or more methods with same name, but the specific method is selected based on the number of parameters declared. We'll now execute a program based on the functionality of additional operator in a different situation. And let's flip back on over to our Eclipse. So in here, I'm going to go back under the dog, and let me just highlight this. And we're going to do the same thing. So you see right here it says public void sound. So this is identical, public void sound. But instead of sending nothing, we're going to send it a string, and we're going to call it angry. Now at this point, you should note that what if it's a happy dog? I would have to add an if-then. If the string angry said happy, then we'd print happy or something else. But we're just keeping it simple. So we've entered another sound identical to the first, but we've added string angry to it. And this is going to print out the dog says growl growl. Now if we go back to our animal main, and here's our dog, same sound, but now we're going to add a string in here. And we put that string in here, we'll go ahead and just call it angry. It doesn't really matter what string you put in here because we haven't sorted out what the string means. For now it just says growl growl. It's going to recompile it. So remember, this is a polymorphism during compile time. And here we have it, the dog says growl growl. So the dog says bow wow, and then the angry dog says growl growl. So there's another thing called operator overloading. Operator overloading is not supported in Java. Authors of Java wanted to keep the language less complicated. Explaining operator overloading, it basically is a way of bundling operations into the call statement and user procedures. It's so that it looks like a math on a paper. You have A plus add B plus C kind of thing, and it's all wrapped up in your call to another statement. This just gets confusing, and it really isn't necessary. So the Java developers decided not to put it in there. So runtime polymorphism. In Java programming language, runtime polymorphism gets handled during the program execution stage. Here the overriding method gets resolved in execution. So far we've talked about compile time polymorphism. As you saw in the program we just wrote, when it's compiling, it does the extend and figures out which overload method to use on there. In runtime polymorphism, method overriding, in Java, the method overriding is a procedure where a child class is allowed to implement a specific class that is already provided in the parent class. For runtime compilation code, or polymorphism, we need to go ahead and introduce the super keyword. Now, from inheritance, you should remember that we can look at super from before, but we're going to use it slightly different. It's kind of doing the same thing as when we did the inheritance, but we're doing like what they call an override during runtime. So the term super is predefined keyword in Java that is used to refer the immediate parent class object or method defined in the program. In this procedure, whenever you create an instance of subclass, then automatically an instance of parent class is also created that will be implicitly referred by the super reference variable. So going back into our animal sounds, let's go in here to dog. And if we add a super dot sound in here, this is going to reference whatever our extend is, because the dog extends animal sounds. And so here's our super dot sound. And if we go ahead and we'll run and compile this, and you can see here that it comes down and it says the dog says growl growl, because that's what we had it system out print line to. And then the super, animals make different sounds. And so if we go back to our animal main, this is what it's calling right here. It's going back into sound under the animal mains, and it's printing out or doing whatever it does here. At this point, we usually have it return something, so you can look up whatever the original class was using. So getting back to these two setups, whether you're using the super to use a runtime polymorphism, because that's what's happening during runtime, versus compile time polymorphism. During compile time polymorphism, method call is handled by the compiler itself. So the program maybe take a second more to compile, but it runs faster. In the runtime, the method call cannot be handled by compiler in the execution stage. So if you have any errors, it's not going to show up either. During the compile time, we have compile time polymorphism is less flexible as it needs to handle all method calls in compile time. So you really, in runtime polymorphism, it exhibits higher flexibility as the method call gets handled at runtime coming in. The execution period for compile time polymorphism is less. That's what I was just talking about. It compiles it, so the compiling takes maybe a little bit more. But if you're executing the same program over and over and over again, once it's distributed, it's going to run faster. Then, of course, with the runtime polymorphism, the execution period for runtime polymorphism takes longer. It's just a little bit more. Usually in most programs you don't notice this, but if you're executing the same script 1,000 times, suddenly that 0.01 second is a lot more. It suddenly is adding up a second each time it goes through the 1,000 iterations. Then with the compile time polymorphism, integrating the right method call with the right method is done in compile time. And of course in runtime, integrating the right method call with the right method is done in runtime. Again, that's another delay because it has to figure out what it's doing. It's not already pre-mapped out. And finally, compile time polymorphism occurs during method overloading and operator overloading, where runtime polymorphism occurs during the method overriding. Advantages of polymorphism: programmers' code can be reused via polymorphism. Number one goal of a programmer is to reuse the code as much as possible so you're not reinventing the wheel over and over again. Advantages of polymorphism: supports single variable name for multiple data types, reduces coupling between different functionalities. And some of the disadvantages of polymorphism that can come up is that polymorphism ends up raising performance issues in real time. You can see whereas you're loading all these different things, you might end up creating loops you didn't know you were doing. Polymorphism reduces readability of the code. Sometimes your actual code, everything you look at in Java is polymorphism, all based on a primary object. So you could have a very complicated setup, and then it actually is very easy to read when you actually put your final variable in there. But when you're going through lines and lines of code, it can be really hard to figure out what's going on as you loop through all these different inherited modules or classes. Programmers find polymorphism difficult to implement. Just depends. The more you use it, the easier it is.
Say you had to print hello all 3 times. You could do it by typing hello all in the system 3 times. But what if you had to print 100 times? What if you had to print 1,000 times? The solution to this is the use of looping statements. There are 3 types of loops that are used in Java: for loop, while loop, do while loop. When some condition evaluates to be true, these loops execute a set of instructions.
What exactly is a Java collection? A Java collection can be generally defined as a collective unit of objects in the form of a group. For example, a group of numbers of integer data type, etc. Moving forward, we enter into our next topic, where we face the Java collections framework. This will help us understand Java collections in a little more detailed way. A Java collection framework represents a unified architecture for storing and manipulating a group of objects. Its architecture includes the following: an interface, a class, and the Java Collections API. To understand these in a much better way, we shall now go through the Java Collections hierarchy. The utility package java.util contains all the classes and interfaces that are required by a collection framework. The collection framework contains an interface named as an iterable interface, which provides the iterator to iterate through all the collections. This interface can be extended by the main collection interface, which acts as the root for the collection framework. All the collections extend this collection interface, thereby extending the properties of the iterator and the methods of this interface. The following figure illustrates the hierarchy of collection framework. Out of the complexities, we have the interface and the classes as the major part of the collections. Now, let us understand each one of them at one step at a time. As you can see on the screen, we have the iterable class, which is implemented by the collection class, and this particular collection class is further implemented by list, queue, and set. And moving ahead, we have the following classes which have implemented the list, queue, and set classes. In the list, we have array list, linked list, vector, stack, and on the other hand, on the queue, we have priority queue, dequeue, and array dequeue. And finally, on the set, we have the hash set, linked hash set, sorted set, tree set, etc. Now moving further, we will enter our first Java collection, which is none other than the interface. So the first one is an interface. An interface can have methods and variables, but the methods declared in an interface are by default abstract. That is, only the method signature is available, not the body. Interfaces specify what a class must do and not how it must do. It is a blueprint of a class. Now, a Java collection is a foundation to the Java Collections framework. Note that all the collection interfaces are generic. For example, public interface collection is the syntax for the generics, and when we declare the collection, we should use it to specify the type of object which it can contain. It helps in reducing runtime errors by type checking the objects at compile time. To keep the number of core collections interface manageable, the Java platform doesn't provide separate interfaces for each variant of each collection type. If an unsupported operation is invoked, a collection implementation throws an unsupported operation exception. Now, under the collection interface, we have many interfaces that we should use for data manipulation. A few of the major ones are set interface, list interface, dequeue interface, queue interface, map interface, sorted set interface, sorted map interface. Don't worry, those are a lot of interfaces, but we will discuss each one of them in a detailed way along with a practical example for a better understanding. So the first one in the docket is the set interface. A set is a collection that cannot contain any duplicate elements. This interface model is the mathematical set abstraction and is used to represent sets such as a deck of cards. The Java platform contains three general-purpose set implementations: the hash set, tree set, and linked hash set. The set interface does not allow random access to an element in the collection. You can use an iterator for each loop to traverse elements of a set. Now, for a better understanding, let us go through a practical example. I have prepared a code document for all the programs that I am going to explain to just save time. You can always have access to it. All you need to do is just ask for it in the comment section below. So you can see on my screen we have an example for set interface. In this particular example, we are going to store the elements 21, 23, 43, 53, 22, and 65. So let's try to execute this program and see the output. So you can see the elements stored in the set interface are 65, 21, 53, 22, and 23, 43. So the sorted set is here, which is the 21, 22, 23, 43, 53, and 65. And the first element being 21 and the last element being 65. So this is how the set interface practically works. Now let's move ahead into our next type of interface, which is none other than the list interface. So what exactly is a list interface? The list interface is an ordered collection that can contain duplicate elements. You can access any element from its index. The list is more likely an array with dynamic length. The list is one of the most used collection types. An array list and linked list are the implementation classes of the list interface. The list interface provides useful methods to add an element at a specific index, to remove and replace elements based on the index, and to get a sublist using the index. For a better understanding, let's check out an example. So this particular program is based on list interface. So we are going to add in 3 names, which are David, John and Stacy, into our list, and also we have a 4th addition, which is Stacy again. Just to check if the statement is true, it says list interface also allows duplicate elements unlike the set interface. So let's try to run this program and see the output. So you can see the program got successfully executed and the names David, John and Stacy are added into the list. Now let's come back to our program and remove this commit and try to run again and check if the 4th element, which is the duplicate of the 3rd, Stacy, will be added into the list or not. So as you can see, the program got successfully executed and the 4th element, which is Stacy, the duplication of the first one, got successfully inserted into the list. So this is how the list interface works. Now let's move ahead into our next type of interface, which is the queue interface. So what exactly is a queue interface? Queue is a collection used to hold multiple elements prior to processing. Besides basic collection operations, a queue provides additional insertion, extraction and inspection operations. Queues typically, but do not necessarily, order elements in the FIFO or first in, first out manner. Among the exceptions are priority queues, which order elements according to a supplied comparator, or the elements in natural ordering. Whatever the ordering used, the head of the queue is the element that would be removed by a call to remove or poll. In a first in, first out queue, all new elements are inserted at the tail of the queue. Now for a better understanding, let's go through a practical example. So as you can see, the program on my screen is an example for queue interface. So in this particular queue, we are going to store the names of fruits, apple, mango, grapes and banana, and apple being the head of the queue and banana being the tail of the queue. Now let's try to execute this program and see the output. So we are also going to count the size of the queue, which is 4 basically in the first. After that we are going to remove the element grapes from the queue. So the command is queue.remove the element name. So after that the grapes element has been removed from our queue. We have the latest size of the queue as 3. Now after that we are also going to check if the element apple is included in the queue or not. So for that statement, yes, the element apple is included in the queue and the result is true. So this is how the queues work, and let's move further. And in the next phase we have the dequeue interface. So what exactly is a dequeue interface? So a linear collection that supports element insertion and removal at both the ends is called as a dequeue interface. The name dequeue is short for double-ended queue and is usually pronounced as DEQ. Most dequeue implementations place no fixed limits on the number of elements they may contain, but this interface supports capacity-restricted dequeues as well as those with no fixed size limit. This interface defines methods to access the elements at both the ends of the dequeue. Methods are provided to insert, remove, and examine the element. For a better understanding, let's check out an example. So you can see on my screen we have a program for dequeue interface. So here we are going to add in some elements into our dequeue and then also try to remove the first element and print the updated dequeue. Now let's try to execute this program and see the output. So as you can see, the program got successfully executed and the elements which we tried to push into the dequeue were 52, 10 and 21. 52 is being the first element and the 21 is being the last element. So we tried to remove the first element, which is the 52. So after that the updated dequeue is having 2 elements which are 10 and 21. So this is how the queues work. Now let's move ahead and learn our next type of interface, which is the map interface. So what exactly is a map interface? A Java map is an object that maps keys along with its values. A map cannot contain duplicate keys. Each key can map to at most one value. The Java platform contains three general-purpose map implementations, which are the hash map, tree map, and linked hash map. The basic operations of a map are contains key, contains value, size, and is empty. For a better understanding, let us check out an example. So this particular example on my screen is an example for map interface. Here we are going to add three elements and map them as 1 as cricket, 2 as hockey, and 3 as archery. Now let us execute this program and see the output. So you can see the program got successfully executed and the elements are mapped with their keys, and the element cricket is mapped with the key 1, and similarly hockey with key 2 and archery with key 3. So this is how the map interfaces work. Now let's move further into our next type of interface, which is the sorted set interface. So what exactly is a sorted set interface? So a sorted set is a set that maintains its elements in ascending order. Several additional operations are provided to take advantage of the ordering. Sorted sets are usually used for naturally ordered sets, such as word lists and membership roles. For a better understanding, let's check out an example based on sorted set interface. So you can see the program on my screen is an example for sorted set interface. So here we are going to add in Bob, Sean, and Jennifer into our set, and we are going to print the same. Let's try to execute this program and see the output. So you can see the program got successfully executed and we have our elements printed in the sorted set, and you can see the names are been arranged in the form of ascending order according to the alphabets which have started in the first position. So this is exactly how the sorted set interface works. So the last one in the interfaces is the sorted map interface, a map that maintains its mapping in an ascending key order. This is the map analog of sorted set. The sorted maps are used for naturally ordered collections of key value pairs such as dictionaries and telephone directories. Now for a better understanding, let's check out an example based on map interface or sorted map interface. So you can see the program on my screen is an example for sorted map interface. So here we are going to add in the elements John, Molly, Aaron, and Daisy into the map interface. Now along with the names, we also have their aggregates, which is 76.5 for John, 87.3 for Molly, and 78.2 for Aaron. And for Daisy we have 73.4. Now finally we are going to fetch the data of Molly, which is the aggregate of Molly. Now let's try to execute this program and see the output. So you can see the program got successfully executed and Molly's aggregate is 87.3. So this is how the map interfaces work. Now let's move ahead into our next topic, which is the Java collection classes. So now that we have finished the Java collection interfaces, let us have a quick understanding of Java interface methods. So the first method is the add method. The add method is used to add an object to the collection, and next is the isEmpty method. This method returns the true if the collection contains no elements. Followed by that we have the clear method, and this method is used to remove all the elements from the collection. Followed by that we have the remove method. This method is used to remove the given object from the collection. If there are duplicate values, then this method removes the first occurrence of the object. Next to the remove method we have the size method. So the size method is used to return the number of elements in the collection. So after the size method we have the stream method. The stream method is used to return a sequential stream with this collection as its source. So the next method we have is the toArray method. So the toArray method is used to return an array containing all the elements in this collection. Followed by that, we have the hashCode method. This method is used to return the hashcode value for this collection. Next, the equals method. The equals method is used to compare the specified object with the remaining elements in the collection. Followed by that, we have the iterator method. So the iterator method is used as an iterator over the elements of the particular collection. And finally, we have the contains method. So the contains method returns true if a specified element is existing in the collection and false if it is not present. So with this, we finish the collection interface and collection interface methods. Now we will move ahead into our next topic, which is none other than the Java collection classes. So what exactly is a class? A class is a user-defined blueprint or prototype from which objects are created. It represents a set of properties or methods that are common to all the objects of one type. Now we'll start up with the first one, which is the hash set class. So the Java hash set is the basic implementation of the set interface that is backed up by the hash map. It makes no guarantee for the iteration order of the set and permits null elements as well. So this class offers constant time performance for basic operations such as add, remove, contains, and size. Assuming the hash function disperses the elements properly among the buckets, we can set the initial capacity and load factor for this collection. The load factor is a measure of how full the hash map is allowed to get before its capacity is automatically increased. For a better understanding, let's go through an example. So on my screen you can see a program which is an example for hash set classes. So inside this, we are going to store some names which are the names of the manufacturers of bikes along with null values. So we have added in two null values to just check if it allows two null values at once. So basically it only should allow one null value. So let's check out how does it perform. So you can see the program got successfully executed and the null value is stored only once, that too in the first location. So this is how the hash set classes work. Moving further, we will deal with the next type of class, which is the tree set class. So a tree set class is a navigable set implementation based on a tree map. The elements are ordered using their natural ordering or by a comparator provided at set creation time, depending on which constructor is being used. This implementation provides guaranteed logged time cost for the basic operations such as add, remove, and contains. Note that the ordering maintained by a set, whether or not an explicit comparator is provided, must be consistent with equals if it is to correctly implement the set interface. Now, to understand in a much better way, let us go through an example. Now we are going to add in some numbers into the tree set using the add method. Now let's execute this code and see the output. So you can see the numbers are added into the tree set and the numbers are ordered in ascending order, which is 0, 18, 88, 748, 983, 8476. Now let's move further into our next type of class, which is the array list class. So array list in Java is a resizable array that is an implementation of list interface that allows null elements. So in this class we have three types of arrays, which are one-dimensional arrays, two-dimensional arrays, and three-dimensional arrays. Now let's check out the one-dimensional array. So a one-dimensional array looks similar to this, where we have the array index and the element present in the array. So here our indexes are A0, 1, 2, 3, and 4, and the elements which are shown here. To understand one-dimensional arrays in a much better way, let's go through a sample program. So you can see the program written on my screen is an example for one-dimensional array, and we are going to store the elements 10, 20, and 30 into my array A. So you can see the program has been successfully executed and the elements have been added into my one-dimensional array. Moving further, we will discuss the two-dimensional arrays. The two-dimensional arrays are completely similar to one-dimensional array, but the only difference is the index numbers Earlier we had index number, but now we have index numbers. Now using these index numbers, we can represent the elements in a matrix form. So to understand this in a much better way, let's go through a sample code. So you can see this particular program in my screen is an example for two-dimensional arrays. So here we are going to add in elements 1, 2, 3 and 4 in the matrix form, and we are going to use 2 for loops to print that. Now let's execute this program and see the output. So you can see we have the elements 1, 2, 3 and 4, and the elements are printed in the matrix form. At the array index location 0, 0 we have 1, 0, 1 we have 2, and 1, 0 we have 3, and 1, 1 we have 4. So this is how the two-dimensional arrays work. And finally, let's deal with the third type of array, which is the multi-dimensional or three-dimensional array. So you can see the three-dimensional array is completely similar or a little bit similar to the two-dimensional array, but the only difference is we have a third vector here. So next up we have the linked list. Linked lists also come under Java collection classes. There are 3 types of linked lists, which are single linked list, doubly linked list, and circular linked list. Now let's check out each one of those. So the first one is the singly linked list. So you can see in a singly linked list, each memory segment is divided into 2 parts. So the first half of the memory location is given for the element, and the second half of the memory location is dedicated for the address. So this particular address is used to point to the next element or the next memory allocation, which stores the second element, similarly the third. So this is how the singly linked list works. So the last memory allocation is called as the tail, and the last address will not store nothing but null, which indicates the end of the singly linked list. Now to understand singly linked list in a much better way, let's try to execute a sample program. So you can see the program on my screen is an example for singly linked list. Now we are going to add in the elements 1, 2, 3 and 4 in the form of a singly linked list. Now let's try to execute this program and see the output. So you can see the program got successfully executed and the elements are 1, 2, 3 and 4. Now let's move further and try to learn the next type of linked list, which is the doubly linked list. So the doubly linked list is completely similar to that of the singly linked list, but the only difference is we have 2 address locations. So the first address location of the head stores null, and the last address location of the tail stores null, which indicate the start and end of the doubly linked list respectively. So here in the second memory location you have 2 addresses. So the first address points to the previous element and the next address points to the next element. So to understand doubly linked list in a much better way, let's try to execute a sample program. So as you can see, the program on my screen is an example for doubly linked list, and we have the node which has the data and previous address, next address. Now let's try to execute this program and see the output. And the elements that we are going to store in this particular doubly linked list are 1, 2, 3, 4 and 5. So as you can see, the program got successfully executed and the nodes are 1, 2, 3 and 4 and 5. So this is how the doubly linked list work. And now let's check out the third type of linked list, which is the circular linked list. So there are similarities between the previous linked list and the circular linked list. So the circular linked list makes it circular based on the last address location. So this particular address location points to the first element back again. So this is how it becomes a circular linked list. So to understand this in a much better way, let's check out an example for it. So you can see the program on my screen is an example for circular linked list. Now let's try to execute this and see the output. So you can see we have successfully included 1, 2, 3, 4, 5, 6 and 7 and 8 into our circular linked list, and they are printed on the screen. So this is how the circular linked list work. So moving further, we will try to understand the next type of classes in Java collections, which is the hash map class. So hash table is based on the implementation of map interface. This implementation provides all the optional map operations and permits null values and the null key. HashMap class is roughly equivalent to hashtable, except that it is unsynchronized and permits null. This class makes no guarantee for the order of the map. Now, for a better understanding, let's go through a sample program. So this particular program on my screen is an example for HashMap class. So here we are trying to load the data, which is the name of the manufacturer and their bike. So let's execute this program and see the output. So you can see the program got successfully executed, and we have the manufacturer and their made bikes. Now moving further, we will deal with the next type of class in Java collection, which is the tree map class. So the tree map is based on navigable map implementation. The map is sorted according to the natural ordering of its keys or by a comparator provided at map creation time, depending on the constructor used. Now let's check out an example for better understanding. So you can see the program written on my screen is an example for tree map class. So we have the roll numbers and the names of students here. Now let's try to execute this program and see the output. So the program got successfully executed and the result has been printed on the output console. So we have the roll numbers of the students and their names: Amber, James, Violet and Reynolds, along with their respective IDs. So now with this, we complete the Java collections classes. Now we move into our next topic, which is the collection API algorithms. So the first one is sorting. Sorting does the job of ascending and descending numbers based on the algorithm written by the user. For a simple example, we shall consider the bubble sort algorithm for this one. So you can see on my screen we have an example for bubble sort algorithm. So we have the elements 2, 89, 39, 48, 6, 28, 1, 2 and 33, which are ordered in an unorderly manner. Let's try to execute this program and order them. So you can see array before bubble sort is 289, 38, 48, similarly 33, and after the bubble sort we have the sorted array, which is 1, 2, 6, 28, 33, 39, 48 and 289. So this is how the bubble sort works. Now let's move further and understand the next type of API, which is the shuffling algorithm. So the shuffling algorithms are designed to destroy the current arrangements. They are employed on creating randomness in the list. So for a better understanding, let's check out an example. So you can see the program written on my screen is an example for shuffle algorithm. So we have an array which has the elements completely sorted in ascending order, which is 10 to 100. Now when we run the shuffle algorithm, these elements will be completely shuffled according to a random order. Now let's try to execute this program and see the output. So you can see the elements which were in an ascending order are now completely in disorder. So this is how the shuffling algorithm works. Now let's move further and understand the next type of algorithm, which is the searching algorithm. Searching algorithm is employed to search an element in the list or array based on the type of searching mechanism used. Now for example, let's use the binary search. Now you can see a program on my screen which is an example for binary search. So we have the elements 1, 2, 3, 4 and 5 in our array. Now what we are going to do is search for the element or the key element 2 in our array using the binary search algorithm. Now let's execute this program and see the output. Now you can see the program got successfully executed and the output says the element which you're looking for is found in the index location 1. So this is how the binary search algorithm works. Now let's move further and understand the next type of algorithm, which is the composition algorithm. So the definition says the frequency and disjoint algorithms test some aspect of composition of one or more collections. So the frequency counts the number of times the specified element occurs in the specified collection. So the disjoint determines whether two collections are disjoint, that is whether they contain no element in common or not. Now to understand it in a much better way, let's go through an example. So you can see on my screen there is an example for composition. Now let's run this program and see the output. So you can see the program got successfully executed and the elements are completely disjoint. Now moving further, we will enter into our next topic, which is based on the benefits of Java collections. So there are various benefits of Java collections. Out of those, the major benefits are software or code reusability. So the Java collections enable code reusability to save time. Followed by that, the ease of designing APIs. So the next two ease of designing APIs, we have the simplicity in learning and using APIs, and finally, increased speed in programming. So these were the major benefits of Java collections. What is an exception? So an exception is defined as an event that arises due to an unexpected input or logical failure in the program. This may not be considered merely as an error, but it surely does impact the normal functioning of the program segment. Now, these types of exceptions are resolved by the most efficient mechanism called exception handling. Exception handling is not any rocket science, but a simple mechanism that drives the compiler to the next statement by making the compiler understand that the input obtained or the malfunction that arose is just an unexpected or an unnecessary event which can be ignored by sending the user with a relevant message about the exception arose. For a better understanding, let us go through a small example. So as you can see on our screen, we have typed in a program. So according to this program, we are going to access a file called data.txt from the C drive. So this particular data.txt is not really existing in the C drive. So when we run this program, we will face an exception that says file is not found. So let's try to run this program and see. So as expected. So when we run this program, we get that this particular file, what you're looking for, which is data.txt, is not found. Or in other words, it is not present in the specified location. So this is how the exceptions work in Java. Now followed by this, we will move ahead into our next topic, where we will understand the meaning of an error. So what exactly is an error? So here, we are trying to learn about the error just to eliminate the ambiguity between an exception and an error. Also further, we will discuss the major differences between them. But now, let us go through the term error first. Unlike an exception, an error poses a serious potential threat to the program, or sometimes it is even capable enough to collapse an entire software. So basically, an error is occurred due to syntax error or some logical error while coding. So we have a sound understanding of an exception and an error. Now let us move further and learn the differences between the both. Error versus exception. So some of the major differences between an error and an exception are: an error is classified under unchecked type, whereas on the other hand, an exception is classified under both checked and unchecked. The next difference is, if a program encounters an error, then it turns out to be completely irrecoverable until the error is resolved. Whereas in the case of an exception, if the program encounters an exception, then the program is easily recoverable. Followed by that, the third difference is, an error belongs to the package called java.lang.error. On the other hand, an exception belongs to the class java.lang.exception. The fourth difference says that an error can be encountered only during the program's runtime, whereas on the other hand, an exception can be expected both during the runtime as well as the compile time. Finally, we will mention an example for both an error and an exception. We can consider the input and output error as an example for error, and on the other hand, we can consider divide by zero exception as an example for exception. So with the differences discussed, we will now move ahead and have a look at the exception hierarchy in Java. The hierarchy of errors and exceptions is really simple. There is one root class called the throwable. Now, the throwable class is basically inherited from object which comes from the superior root called java.lang. Now, the throwable class is inherited by two child classes which are none other than the error and an exception. Further, an error is inherited by different types of errors. For example, JVM or Java Virtual Machine error, memory error, and also in some cases, some of the errors are caused by the incompatibility of the IDE or the framework which you are using. Next up is the exception. Now the exception is inherited by few more exceptions which are mentioned as below. The exceptions can be input-output exception, SQL exception, class not found exception, runtime exception, and many more. Further, the runtime exception is inherited by some more, which are the arithmetic exception, number format exception, etc. Now that we have a good understanding of the exception hierarchy, let us move ahead and check the differences between checked and unchecked exceptions. So the first one, which is the checked exceptions. These are really simple exceptions and can be defined as follows. An exception that pops up during the compile time is called as the checked exception. It is not serious and is completely ignorable. Followed by the checked exceptions, we have the unchecked exceptions. On the other hand, the unchecked exceptions are defined as an exception that pops up during the runtime is called as the unchecked exception. It is considered as serious and is caused by logical errors. So to understand checked exceptions in a much better way, we shall go through an example. So this particular example is based on checked exceptions. So basically, we have a text document called data.txt in the location documents, username, users, C drive. So this particular data file has 5 lines. So we are going to access the starting 3 lines of this particular file, and basically when we try to run this program, we will face some of the major exceptions, which are unhandled exception type input output, and again the same exception, and here file not found exception. So these exceptions are errors. So to understand checked exceptions in a much better way, we shall go through an example. So this particular code segment here is trying to read a document from C drive, which is data.txt. So this particular data.txt has 5 lines of text. So what we are going to do here is try to type in a for loop and try to read the first 3 lines of this particular document. So basically when we run this program, we will face some of the exceptions called file not found exception, input output exception, and another input output exception. So we can resolve this particular program with small modifications to the program, and then if we run this program, then we can find our lines. So the lines in the data.txt file were, hello, welcome to Simplilearn. We are an e-learning company. Our certification is recognized by major MNCs. Enroll and upskill. So this particular example was for checked exceptions. Now, we will also go through an example for unchecked exceptions to learn it in a much better way. So this particular example is based on unchecked exceptions. This particular program is really simple. We have an integer type array, and inside that we have 10 elements, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So what we are going to do is we are going to access the 11th element of the array, which is not really present. So this should throw an exception. So array index out of bound exception is one of the examples for unchecked exceptions. So with this, we will move ahead into our next topic. Now we know what exactly are checked and unchecked exceptions. Moving further, we will slowly dive into the process of exception handling. In the process of exception handling, we have 5 major keywords. So we will learn each one of them as follows. So the first one is try keyword. The try keyword is used to specify the exception block. In a program, when you specifically type the exception that you might expect to face in your program, then you describe it using the keyword try. Followed by that, the solution for that exception will be defined in the catch block. So the catch block is used to specify the solution. Finally, the finally is a keyword which has the executable code which is completely mandatory for a program to execute. Followed by finally, we have the throw keyword. The throw keyword basically throws the exception when it is found during the runtime. Followed by that, we have the throws. The throws keyword is used to declare the exception. So basically, this is where you declare the kind of exception you are going to expect in your program. Sometimes you might try to type in your user-defined exception, or sometimes you might type in the exception that is default in its way. Or in other words, it might be system-defined. Now that we have a good understanding of the implementation of the exception handling in Java, let us move further and solve some of the most frequently faced exceptions in Java. So with this, we enter into our 7th topic, which is common exceptions faced in Java. So the first one is the array index out of bound. So if you try to store a value in an array or try to access an element in an array which has an address exceeding the array's maximum location value, then this particular exception is thrown. So to understand this particular exception, let us go through a practical example. So as you can see on our screen, we have an array of integer data type. So we are going to store the values 10, 20, 30, 40 and 50 in 5 different locations of the array, which is 0, 1, 2, 3 and 4. Now we are going to provide the address of the required element. So during that process, we are going to specify one location which is more than the maximum location of the array. So here the maximum location of the array is 4, and if we try to provide the location 5, then this program should throw us an exception. So let's try to run this program and see the output. So as you can see, we have our array here. Now the program is requesting us to provide the address of the element required. So what if we provide 5? So now it should throw an exception. So this exception is the array index out of bound exception. Now let us try to run this program again and specify the proper address. So for this time, let's provide 4 and see if we get the output. So as you can see, at the address location, we have the element 50 as we have defined here. Now our program is running perfectly alright. Now let's move ahead into the next type of exception, which is none other than our null pointer exception. If you try to perform an operation on a null value, this particular exception is thrown. So might be a little ambiguous. To understand this particular exception in a perfect way, let us go through a practical example. So here on your screen, you can see that we have a program, and inside the program we have a string called str which stores a text called Simplilearn. Followed by that, we have another string type which stores a null value, which is abc. As you can see, abc is equals to null. Now here we are going to access the value of abc. So here the string abc has a null value and we are trying to access it. So this particular code segment should throw an exception called null pointer exception. Now let's try to execute this code. As you can see, it has thrown an exception called the null pointer exception. So whenever in Java, if you try to access the null values, then the null pointer exception is thrown. Followed by this, we have the next type of the common exception, which is the number format. If you try to store a value with wrong formatting, then this particular exception is thrown. Now to understand this in a much better way, let us try to execute a sample program. So here on the screen, we have a sample program where we are trying to cast a string into integer. So this kind of operation should throw an exception. So as you can see, the program has been successfully compiled and we have our exception here which says number format exception. Followed by this, we have another most commonly faced exception, which is the arithmetic expression. If you try to divide a number by 0, this particular exception is thrown. Now let us go through a practical example. Now you can see we have a sample program on our screen where we have two particular numbers, n1 is equals to 0 and n2 is equals to 100. So here what we are trying to do is we are going to divide the number 100 by 0, which is practically not possible. So when we try to execute this particular program, then we should be getting an exception that says you cannot divide a number by 0. So there you have your personalized message which says the divider cannot be 0. Try a different number. So this is how the automatic exceptions work. So with this we have come to our last topic, which is the best practices to be followed while working with exceptions in Java. So the first one is use exceptions conservatively. So exceptions have proven that they can be costly if used recklessly or unnecessarily. So it's better we use Boolean values to indicate successful implementation of smaller operations. For example, if you specify a particular operation and it successfully gets executed, then you can just notify the user by specifying a Boolean value which can be 1, or in the case of failure, you can just specify the number 0. Next after that, we have the customized exceptions. It is a very good practice of customizing your exceptions in the design time rather than planning them on the go. So in other words, we can consider this as if you're planning to design a software, then in that particular stage itself, you must also evaluate the kind of exceptions you might face on the process of designing. So tomorrow if you completely design a software and suddenly an exception is popped in your head, then designing or including that particular exception in your finished software might be difficult. So it's better you start planning your exceptions. Followed by that, we have exception logging. Keep track of the exceptions, and this process comes handy as the user understands why exactly a particular exception has popped up. Followed by that, we have early throw and early fail. An exception should be thrown as early as possible and should be resolved in the same pace. And then we have the closing resources. Since exceptions halt the complete program, we must make sure that the system resources are shut so as to save the resources.
Java projects. So in our agenda, we will get started with the top 10 project ideas for 2022. Followed by that, we will learn the core Java projects. So we will go through some exciting core Java projects, for example, online banking system and ATM Java project and many more. Followed by the core Java projects, we will create an advanced Java project along with Spring framework. So I hope I made myself clear with the agenda. Now without further ado, let's get started with Java projects for 2022. Over to our experts.
The top 10 Java project ideas. So the first project that we will deal today is the online courier management system. So this particular project motto is to deal with the courier management system. The system will be used for day-to-day activities like buy, return, booking, delivery and non-delivery, and self-pickup, etc. It is not easy to build this particular project all alone, as the technicality of the project is a little complex for a single programmer. I would suggest you that you get a team with you and also look out for some automation in the process by developing the relevant software. Robotic process automation is the new normal in today's life. The web-enabled interface allows the user to log in from anywhere in the world and track their courier and also view the customer rating. The system is designed to integrate with financial accounting to eliminate duplication of data entry and is also scalable to grow along with your company. The system needs to be built with user-friendly screens, rich in functionality and features, and finally the major part, it should maintain a high level of data integrity. So with that abstract discussed, now let's look into the features offered by this particular online courier service. As discussed in the abstract, this particular project should be providing the features of order and dispatch of the product, information regarding the customer, delivery executive, and followed by the delivery executive, we should be also having a payment window which manages the accounts and bill reports. So having said that, let's now move into the software requirements. So the software used in this particular project is the programming language, that is Java. Database is the Microsoft Access and some convenient RPA tools. And finally, the IDE. The IDE for this can be anyone which has a good support for Java. The most preferable one would be the Eclipse. And then comes the IntelliJ, NetBeans, and many more. Now, creating this kind of a project will give you a valuable experience based on building a fully fledged e-commerce website or an application. I mean, this is how the world's leading applications like Amazon, Flipkart, Zomato, etc. are basically planned and have reached greater heights today. This kind of project on your resume could make a huge difference. And who knows, tomorrow you might even get into one of those companies and start working on their projects or build a company of your own. Followed by the online career system, we have the online voting system. Now, thinking apart from getting a job or starting a new company of your own, this is something that we all need today in this pandemic situation especially. In the current scenario, the internet has brought all the ease to our living room. It has replaced physical banking to internet banking, ordering food online, buying movie tickets, buying clothes and household items, to consult your doctor for minor issues, bill payments, and many more. Yet, for quite a long time, going to polling booth and standing in a long queue to cast a vote has been persistent, and it has been challenging for the government to motivate common people to participate in the election system and cast their vote, just because there is no other way to do such thing as such an online voting system. But all the credit can be achieved by software engineers who can make it possible soon for everyone to cast their vote to their respective candidate as their own choice with an unmatchable ease. This can be done just by click on their fingers. This is an advanced Java project developed to show online voting functionality. Followed by the abstract, we will get into the technicality of this particular project. So the first phase of this particular project has the admin phase, where the admin has the right to manage the candidates, manage the voters and their profiles and passwords, and finally election results. Followed by the admin, we have the voter or the user of this particular application. The voter or the user gets to register himself or herself into the application. Followed by that, he can use the login and logout options. And next we have the profile and password managements. So followed by that, we have the option to choose the positions to vote, and finally to cast the vote. Now this particular project is an advanced level Java project developed to show online voting functionality. It showcases the use of Java servlets, HTML and CSS. Again, coming into the IDE. The IDE for this can be anyone who has good support for Java. The most preferable one would be Eclipse and IntelliJ. Followed by the online voting system, we will now continue with the online healthcare management. Named as the corporate Medicare management, this e-healthcare management system is a web-based project developed in Java. The main aim of this particular project is to provide effective management of data related to staff and patients in hospitals or clinics. The features offered by this particular project should be as follows. It should optimize bed occupation. The project should improve the use of operation theaters, avoiding the cancellation of operations. To know how much emergencies affect the administration of the hospital departments or services which include cancellation of operations. To optimize the allocation of human and material resources to wards and shifts. To detect the influence of certain diseases in the hospital services, and finally to find clusters of patients. The software requirement for this particular project are as follows. We need DHTML for the front end and Java as the programming language, and data mining tool which is Weka, and Oracle for the database, JavaScript for the scripting language, and finally Tomcat as our server. The e-healthcare management system is a web-based application that assists the management of staff, doctors and patients in an easy, comfortable and effective way. Here, the concept of data mining plays a vital role to develop an effective healthcare management system. The proposed application aims to create a friendly working environment for any healthcare centers to overcome the drawbacks in the existing system of healthcare management. This system is very reliable and flexible from all aspects. so new features and modules can be easily integrated into the system in the future. Followed by the e-healthcare management system, we have a new normal, online banking. Not interesting and arousing for a normal person, but for a hardcore programmer, it is as exciting as a roller coaster ride in an amusement park. Because this is how the major national and multinational banks implement their banking facilities in a wide range so that their customers could experience the ease of banking at their fingertips. One such type of project on your resume could bring major highlight to the recruiter, especially if the recruiter is from a banking or financial based company. Online banking system project is a model internet banking site. This project should enable the customers to perform basic bank transactions by sitting at a corner of their home or office through a phone or laptop. The customers can access bank's website for viewing their account details and perform the transactions on account as per the requirement. Bank employees can log in and add customer and account information to perform transactions with internet banking. With internet banking, the brick and mortar structure of the traditional bank gets converted into a click and portal mode, thereby giving the concept of virtual banking a real shape. Thus, today's banking is no longer confined to branches. E-banking facilities banking transactions by customers round the clock globally. The features you can offer through this particular project are homepage for online banking site, creation of new accounts, login and log out, manage profiles and passwords, view the balance of the account, deposit the amount into the selected account, withdraw amount from the selected account, transfer the amount from one account to another, close the account. So the software requirements for this particular project are Java programming language and JavaScript for scripting language and Oracle for database and Tomcat for server. So followed by the online banking project, we have the online examination project. Online exams are normal for us nowadays, but this is totally limited to high-end exams like CET, GRE, CAT, etc. The requirement for this particular project is increasing day by day because of the current scenarios. Many schools and colleges have now turned towards the online education system and are looking forward to hosting online exams for student safety. Online examination is a simple project developed to provide an online platform for faculty and students to conduct online examinations and their evaluations. This particular project has two parts. First is the admin part. Admin has the right to add students, create one-time login, adding questions, receive answers, and finally to evaluate. Followed by the first part, we have the second part, which belongs to the students. So the students can log in, update their profile and password, select answers for the MCQs, write answers to questions, and finally closing the session and log out. This particular project can be made a grand success by making use of simple Java servlets and Java programming languages and server like Apache Tomcat. Followed by the online examinations, we have the Smart City. Smart City Java project can be a web-based software developed to store the details of a particular city. The main purpose of the project is to help tourists and other visitors to a city by providing information about hotels, transportation facilities, air ticket booking, shopping details, city news, etc. The Smart City Java project serves the visitors as a guide of the city, and hence the project is called as City Guide Project in Java. Using this project, the details of the city can be accessed from anywhere at any time. The implementation of this city project promotes tourism and business effectively. Hotels can be searched more easily from anywhere. With the help of this online software, students can look out for academic institutes located in the city. You can view the complete map of the city using this project. Followed by the abstract, we have the features of this particular project. The features offered in this particular project are login, update profile and password, search for the options, select an option like booking a ticket or hotel or anything like transportation, etc. And finally selecting that particular option, booking that option and payment window. Finally, the confirmation of the order. This particular project can be fulfilled by using the following software tools as mentioned below. They are the Java programming language, Tomcat server, scripting languages like JavaScript, etc., and database as Oracle for interactive data storage. This could be escalated to another level by following. Design drones that can act like a cop act as a tourist guide for the people touring the city, a drone that has capability to take pictures, videos of suspected activities and store it for future reference. A drone can intimidate a cop if any suspected activities are detected. There can be many drones in the city with different functionalities, and finally, you are required to implement the functionality of the drone to the users to interact with the drone. Users could be travelers or cops or travel agents or cab agents. The code for all these projects are provided in the description box below. Followed by the smart city, we have the bug tracking system. The bug tracking system is a web-based application developed by Java programming language for software companies. The main aim of this project is to manage the errors or bugs that occur during the software development phase and cycle. After the implementation of this project, the employees can update the issue details, solve the issues, and update the system for any location with internet access. Below are the features of this project, and source code of this project is linked in the description box below. Coming into features, the software is applicable in managing the bugs that occur during the development of software and tracking the older issues. It facilitates searching the facility to bug history and solution. The system is fully secured and authentication method is adopted to manage security. It stores the older bug reports so that they can easily be solved when they reappear. The application helps the project manager in evaluating the works of the employees. And finally, the proposed software is capable of auto update when the latest version is available. So the software requirements for this particular project are programming language, which is Java, web-based applications such as JDBC, JNDI, servlets, JSP, and Oracle database or Access database as the database. Followed by that, the server deployment is Red Hat, JBoss, AS, etc. And the client-side scripting as the JavaScript. And the IDE for this particular project would be Eclipse with all the My Eclipse plugins. And finally, the user interface can be designed using HTML and CSS. So with this, we can move ahead into the next project, which is the facial recognition. The face recognition with OpenCV is an open source computer vision library that has tons of modules like object detection, face detection, and augmented reality. The major features that this particular project offers are managing the use of faces, facilitate face identification, easy login and logout, store face IDs, identify suspects with just images, enhanced way to find cyber criminals. So followed by the features, now we should look into the software requirements to build this particular project. So the programming language we need for this particular project is Java, and followed by the programming language we need the Apache Ant framework, Ming W64, and finally the CMake framework. So followed by the facial recognition project, we have the next project, which is the vehicle recognition. So Java ANPR is a number plate recognition software which implements algorithmic and mathematical principles from artificial intelligence, machine vision, and neural networks. So the features offered by this particular project are high-level language for numerical computation, interactive environment for iterative exploration, mathematical functions, built-in graphics, functions for integrating MATLAB, and many more. So this particular project can be fulfilled by using OpenCV and Java programming language along with some natural language processing algorithms. So followed by vehicle recognition project, we have our last project, which is the speech recognition system. So speech recognizer converts audio to text. Java x.speech.recognition package defines the recognizer interface to build speech recognition plus a set of supporting classes and interfaces. So the features or stages in this particular project are to create a speech recognizer, allocate resources, load and enable grammar, attach result listener, commit changes, and finally provide the process results. So this particular library is readily available in Java, and you can code this project using the Java programming language and an IDE such as Eclipse.
So in this session, we are going to focus on a particular project. And the project we are going to focus is about an ATM application. So you might have interacted with different ATM stores in your cities where you go in, you insert your card, you enter your PIN, and then you can view the balance, you can withdraw some amount, you can also deposit some amount from the ATM. So we will try to look at it from that perspective, and we will see what kind of different Java and OOPS concepts we can use to build such ATM application. This is not a super versatile application, but this is just to give you the idea of how to use those OOPS concepts to build a simple or a complex Java application. So let's start from the options menu class, because that will give us the understanding of what kind of functionality I'm using. And here you will use that I'm using different concepts which I have taught you so far in this particular series. So for example, we are using the IO exception, we are using the hash map class, we are also using a scanner class, which is used to take input from the command line. So this option menu class is extending the account class, and I will come to the account class in a while, but let's see what this option menu class is doing. This particular class has it is using a decimal format money format class, which is to denote what kind of format of money you have. Then we have a hash map, which is storing the couple of records of account number to pin mapping. So we create a map, and inside the get login method, we add couple of entries to the map. Here, the first entry, the first integer, is pointing to the customer number, and the second integer is pointing to the pin of the account of this particular customer number. So if we call the get login method, this method will insert the data. After that, it will ask the customer to enter the customer number, which has to be one of these two. If you provide any other value, then there should be a logic in the application to reject the input. So whatever customer number the customer inputs, we pass that inside this particular method called set customer number. Again, I will come back to that. And once you have provided a valid customer number, then this method is going to ask you to enter a PIN number. And remember, I told you this is the customer number to the PIN number mapping. So whatever customer number you select from here, you will be providing the corresponding PIN number. And again, if you provide an invalid PIN number, you will get an error. So that will all happen inside this try block. And if you enter any invalid characters in the PIN number or the ATM customer number, then you will get an exception, which I am writing inside the catch block. This is all what we have seen so far. After the successful enter of the customer number and the PIN number, I fetch those values from these two methods. Again, I will talk about what these methods are doing. And again, I'm doing some basic validation checks, but things get interesting in this method. So what we covered so far was the get login method. Let me close this method here. So we covered the get login method. The second method, which is defined in this particular class, is the account type. So here we will ask once the customer has provided the customer number and the PIN number, we will ask the customer to provide the account type. This application supports two different account types, which are checking account or a savings account. So the customer has to choose one of them. Again, we will be taking the input from the command line using the scanner class. And then I'm using a switch case. If the customer entered 1, then I will execute some code for the checking account, which is defined here in the case 1. And if the customer entered 2, then the case 2 will be executed. And if it enters 3, then I will exit the application by just printing a sys out. So here I'm using the switch case construct to provide different options to the customer. There's also a default case specified here, which says invalid choice. So this is what is happening in the get account type method. The next method is if the customer has used the option 1, then we call the get checking method. So let's go to the get checking method, which is the next method which is defined in this particular class. So if the customer has selected a checking account, then we provide the following functionality to the customer, which is the customer can view the balance, customer can withdraw the funds, customer can deposit the funds to the checking account, or they can just exit the application. And again, I'm using a switch case here. Based on the customer types 1, 2, 3, or 4, the corresponding case block will be executed. For example, if the customer wants to view the balance, then this block will get executed, and I call the get account type method. If the customer selects the 2 as the withdraw fund, then get checkings with withdraw input method gets called, and then get account type gets called. Similarly, if the customer enters 3, then we deposit the fund, and for that also I have defined a method I will go to the definition of these methods as we go along, but right now we are just building the framework. So the get checking deposit input method will be called whenever the customer selects the option 3. And for option 4, we just exit the application. So this is what is happening in the get checking method. Now, if from the account selection, if the customer selected second option, which was savings account, then we were calling get saving method. So this is where the get saving method is defined. And again, it is following the exact same format as we saw in the get checking method, where we present the following options like viewing balance, withdrawing the funds, and depositing the funds in the savings account. And I have some methods defined here. For example, get saving withdraw input, get saving deposit input. So we define the switch case here based on the customer's choices here. And that is what is happening in the get saving method. So let me close this method as well. And that's all what is defined inside the option menu class. So we ask the customer to enter the customer number, the PIN number from this get login method. Then based on that, we provide the customer the options to choose the account type, whether they can choose the savings account or the checking account. And based on that, whatever account type they use, we call the get checking or get saving method. And inside this method, we provide the customer the other options to either withdraw the money, deposit the money, or view the balance. That is what is happening inside this option menu class. Now let's go to the account class, and all the methods which we saw here will be provided a definition in the account class. You also see this option menu is extending the accounts class, so an inheritance concept is being used here. Let's go to the account class now. So this is the account class where I have defined some private member variables like customer number. So now you will be familiar with the customer number PIN number, which I just described, and also with the checking balance and the savings balance. You can also divide this account class into two child classes, where you have a savings account class and a checking account class. But for simplicity, I've kept it to one class. I'm initializing a scanner input, which will be used at multiple places. And then I have the setters and getters for these 4 member variables. So you see set customer number, get customer number. If you remember, this set customer number was called in the option menu class. If I go back to the get login, once we ask the customer to enter the customer number, we call the set customer number, which gets called here. Similarly, we call the set PIN number, which gets called here. Similarly, once we have said that, we were fetching the values using the get customer number and the get PIN number. And that is also defined here in terms of the getters, get PIN number and get customer number. Similarly, we also have the getters for the checking balance and the saving balance member variables. We do not have the setters for them because they are not technically setters, but we have to calculate the balance. It's not a simple setter where you can just return the value. So now let's look at some of the business functions of the account class. How do you deposit? How do you view the balance? How do you withdraw the balance, etc. So you see these two methods, which are specifically when the customer is trying to withdraw the money from their account. And these methods are basically called internally by other methods. So we will come to that. Let's just understand that we have two methods for calculating the withdrawable amount or executing the withdraw transaction for the checking account and the savings account. Similarly, I have two more methods here, which are calculating the depositing for the checking account and calculating the depositing for the savings account. And then we get the bigger methods, which are using these calculation methods. So I defined 4 calculation methods so far: calc checking withdraw, calc saving withdraw, calc checking deposit, and calc saving deposit, basically withdrawing and deposit for both of the classes. And then we have these business functions called get checking withdraw input and get saving withdraw input, get checking deposit input, and get saving deposit input. So these getter methods are something which were being called from the option menu class, if you remember. If you go back to the option menu class, and if you chose the checking account, you get these options. And let's say you chose option 2, which was withdraw funds, or option 3, which was deposit funds. Then the corresponding methods which were being called were get checking withdraw input and get checking deposit input. And this is the exact same method, get checking withdraw input and get checking deposit input. So if you see what is happening inside this particular method is a couple of sysouts. Then we take the scanner input amount and we convert that amount to the double. After that, we check if the amount which the customer wants to withdraw is smaller than the checking balance or not. And I'm running this condition to check that. If the amount is smaller than the checking balance, then we call the calc checking withdraw method, which was defined right here. Remember, I told you that these 4 calc methods will be used, and this is how they are used. So here I'm actually subtracting the value. So whatever amount the customer wants to withdraw, subtract that from the main balance and then return the new main balance. That's what you do, right? If you have 1,000 rupees and if you want to withdraw 500, you subtract 500 from 1,000 and then you send back the remaining balance. So that is what is happening when we call this method, and then we print the new checking account balance. That is what is happening in the get checking withdraw input method. Similarly, if you chose option 3, which was depositing funds to the checking account, then get checking deposit input gets called, and it is defined right here, get checking deposit input. And here, instead of subtraction, we are doing the addition. So here I'm again doing a condition check that the current balance plus the new amount which has been supplied by the customer from the command line, the total sum of it should be greater than 0. What if the customer entered an amount minus 5,000? I should not allow that. So that's the reason I'm putting this condition in place. And if the current balance plus the new amount which is supposed to be deposited to the account, the sum of it is greater than 0, then call the calc checking deposit method. And this is where the calc checking deposit method is present, and where I'm just doing present balance plus the new amount and returning the new balance. That's all which is being done here. And you will see exactly similar logic running for the savings account as well. If you look at the get saving withdraw input, which is used to withdraw money from the savings account. So I take the input from the command line and I run a condition check that the amount which the customer wants to withdraw should be less than the current saving account's balance. If yes, then call calc saving withdraw method, which is defined here, where I subtract the amount from the current balance and I return the new balance. And similarly, you will see the exact same functionality in the get saving deposit, where we add the money instead of subtracting the money. And this is all what is defined in the account class. So we talked about the option menu class, we talked about the account class, and now we have the ATM class, which is the entry point, which basically initializes the option menu class and calls the get login method. Remember, get login was the first method which asked you to provide the customer number, and then get login called the method to choose the account type, and the account type methods then called the method to choose the option to withdraw, deposit, or exit. So now we have built a fair understanding of what is happening in this application. So let's run this application. So I just ran this application, and let me bring the console here. It's first asking for a customer number. So I will go to the option menu class and I will pick up one of the customer number which I have hard coded here. So I will provide that customer number and hit enter. Then it asks me for the PIN number. So remember, you have to provide the correct PIN number corresponding to the customer number. So I'm taking this PIN number, just copying it and pasting it here. Then this whole code got executed, and then it called the get account type, and the get account type method provided you with these options, which you see here on the screen. So based on what you select, the case block will get executed. And let's say I want to go for a checking account. So I press 1 and I hit enter. Once you select the checking account, the case 1 gets selected and it calls the get checking method. And the get checking method again provides you with another menu, view, withdraw, or deposit, or exit. So let's say I want to deposit funds. So I press 3 and hit enter. It says the current balance is 0 and enter the amount you want to deposit. Let's say I want to deposit 500 and I hit enter. You get the message saying the new checking account balance is 500 and you have successfully deposited the money. And that is what I did for the checking account. Now let's try to withdraw something from the checking account. So you again get back the same option because inside the get checking method, we call once we have successfully done the business operation, we again call the account type method to display the menu again to the user. So let's say again select the checking account class, and this time I want to withdraw the funds. Remember, I've added 500 there. So let's say I want to withdraw, so I choose the option 2 as the choice. Current balance is 500 and it's asking me the amount you want to withdraw from the checking account. So I enter, let's say 100 and I hit enter. When I do that, the new checking account balance becomes 400. So the 100 got subtracted from the 500 and the new balance is shown to your screen. You can do exactly the same thing for the savings account as well. And let's also run a negative condition. So I again select the checking account and I want to withdraw the funds. I choose the option 2. Current balance is 400 and I would like to withdraw 1000. What happens? If you do that, we get a message saying balance cannot be negative. And this is coming from the calc checking method, which is defined here. So what is happening that I wanted to withdraw the funds from the checking account, and here get checking withdraw input got called. Here, this condition was checked. So the checking balance was 400 and the amount I wanted to withdraw was 1000. So 400 minus 1000 is not greater than equal to 0. So it jumped into the else block and it said balance cannot be negative. So this is how you can also build some error conditions in your code which are mandatory and which should be built. Otherwise your application will have a lot of bugs. We can also exit the application. So if you just type 3 and hit enter, you will exit from the application and it will again call the login method where it will again ask you to enter the customer number. So this is how you can run this application, and this was a simple use case for you to show how you can use the different object-oriented concepts like classes, objects, methods, setters, getters, switch case, etc. to build the application with the correct business logic. And this is all I want to cover in this particular session. And in the next session, we are going to have a look at another interesting core Java project just to build our understanding more better about the core Java concept.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Let's get started with walking through a core Java project using all the different OOPS concepts we have learned so far. So in this example, we are going to have a look at a calculator application, and this calculator application supports primarily 4 different operations like addition, subtraction, multiplication, and division. So let's see how do we build that app. So in front of me right now is open the main class. So I have a main app class here, which has a public static void main method. And the first thing we see is a read input class, which is calling a read method. So if you go to the read input class, it has a simple static method here, which is the read method, and it is using the scanner class. If you remember, I talked about the scanner class, which is used to take inputs from the command line from the user. So we initialize the scanner class and we start taking the inputs, and whatever the user inputs in terms of the expression, let's say the user entered 4 plus 5 or whatever, that whole expression gets sent back into this input line as a string, and that comes back here in the input expression. Once we have captured the input expression, the next thing we do is divide the input expression in the numbers and the operators. Basically, an expression would be either something like 4 plus 5 into 3 divided by 2, let's say. Let's say the user entered this expression. So this has either numbers or operators. So that's what we are doing here. we are using the split method of the string API, the string class basically. And this split method is going to split the numbers and operators into two different string arrays. And here I'm providing the split expression that split at every time you encounter one of these symbols. So this, when you execute this particular statement, it is going to return a numbers array, which will be created based on this expression. So you will get an array with 4, 5, 3, and 2. And similarly, in the operator array, you are going to split or pick out the elements every time you receive a number. So this operator array is going to hold this plus sign, this multiply sign, and this divide sign. Hope you get the understanding that we are just splitting the whole expression into two different arrays, where first array is holding only the numbers and no mathematical expressions, and second array is just holding the mathematical operators and no numbers. And we'll see why we need to do that in the upcoming lines. Once I've created this string array, I just want to store or convert these string arrays into a queue. So I convert this array into a list by calling the array.asList. So this expression is going to return a list. And then I'm going to convert this normal list into a linked list, and then going to store this linked list into the queue of numbers. And I'm going to do exactly the same thing for the operator array as well, converting this into a generic list, converting that generic list into a linked list, and then storing this linked list as a queue. So I have an operators queue and I have a numbers queue. Both of them have been stored into a queue now. And then I'm using the poll method. If you remember, the poll method of the queue is used when you want to fetch the first front element, the head element of the queue. So whichever element is sitting at the head of the queue will be taken out the moment you call the poll method. So I fetch the first number from the numbers queue. So in this case, 4 will be fetched here in this variable. And after that, I run a loop on the numbers queue. And I'm going to run this particular loop till this particular queue is not empty. If you see, there's a negation here. So I'm going to pick up numbers one by one from this numbers queue till the number queue becomes empty. And inside the loop, I do this exact same poll operation for the operations queue. So this operations queue is holding all these mathematical operations like plus, star, and divide. So I'm going to pick the head of it. So in this case, plus will be picked up and will be stored in this variable called OPR. And then I'm going to run a switch case on this OPR. Basically, as I told you, in this particular calculator application, we are supporting 4 operations, which are addition, subtraction, multiplication, and division. So I define a case for each of the mathematical expression. So you see there are 4 different cases here. And for each case, I'm initializing a class. If it's a plus sign, then I'm initializing the add class. If it's a minus sign, then I'm initializing the subtract class. For multiplication, I have a class called multiply. And for division, I have a class called divide. Let's have a look at what these classes are containing. So if I go to the add class, first of all, it is implementing an interface called operate. And this operate interface has just a single method called getResults, which is accepting a variable argument array. If you remember, I told you that you can also use a var_arg array. This is called a var_arg expression. This means that this numbers will be an array of arbitrary length. It can be a 1-element array, it can be a 2-element array, it can be a 4-element array, or whatever you supply. But it is still going to be a fixed length array, but the length is going to be dependent upon how much argument you supply to this particular method. So that is what this interface operate is doing. It just has one method declared, which is called getResult, which is accepting an array of numbers. So if the add class is implementing the operate interface, then it has to override the getResult method. And here it is just doing a summation of all the numbers which have been supplied. So if you supply 4 numbers, it is just going to add up those 4 numbers and return the sum. And the exact same kind of logic or similar logic will be seen in other operate classes. So if I go to the subtract class, it runs the exact same operation, but it subtracts the values. If I go to the multiply class, it is also implementing the operate interface, and in the get result, it is just multiplying all the values. Similarly, in the divide class, it is also implementing the operate interface, and it is dividing all the numbers one by one. So it's doing pretty much the same thing in terms of the expression and the logic. The only difference is whether you are using an add operation or a subtract or a multiply or a divide. So we have checked all these classes and the operate interface as well. And let's go back to the main app now. Now you also see that I've defined a reference of operate here, and each of the switch case block, I'm assigning the object type to this interface reference. So I'm using the concept of dynamic binding, which we talked about when we talked about interfaces, that we can also do dynamic binding where we can assign an object to an interface type, and the object type will depend upon the expression. So once we have filled that based on the case, while filtering out this expression and picking up plus, star, and divide sequentially, then we go to the next line outside the switch case block, which is to pick the next number from the queue. Remember, we already did one poll here. So as per this example, 4 was here in this res. And now when we do this number.poll again, 5 will be picked up because that will be the next head of the queue. So we pick up 5 here, and then we call operate.getResult. Now this getResult will be called based on the expression which was encountered first in the queue. Again, looking at the example, the first expression encountered will be plus. So the expression was plus. So the operate type object is of add type. And when you call operate.getResult, the getResult method of add class is going to get invoked, and it is going to sum 4 and 5. This res is holding 4 right now based on what I described here, numbers.poll. And this num is holding the second operand, basically 5 here. So 4 plus 5 gets evaluated here in this case. And then it again goes back here and it checks if the number queue is now empty. No, it is still not empty because we still have 3 and 2 left there. So again, it does the operations.poll and it picks up multiply sign here. Then it again runs the switch case. Since it's a multiply sign, it will go here and it will initialize the operate interface reference as the object of multiply class. Then coming here, it will do a numbers.poll, and this time the numbers.poll is going to pick up 3. So 3 will be picked up here, and then the current value of result, which is already 9, 4 plus 5 was 9. The current value of result will be updated here. So res will be 9 here and num will be 3 here. And when you call operate.getResult, the multiply classes getResult will get called and it will say 9 into 3, which will become 27. It will again go back here to this particular line and it will check again if the numbers queue is now empty. No, it is still not empty because we still have one element left. Then it polls the queue of the operations where the expression divide is present there, which is the only element left in this particular operations queue. And since we have the OPR value as divide, this case block gets called and the new divide class gets initialized. The divide class basically gets initialized. And we come here and we do numbers.poll. Now the last number which is available in this queue is 2, which gets picked up here. And then we again call operate.getResult. This time, since the operate operate reference type was of divide class type, so when we call operate.getResult, the divide operation or the getResult method of the divide class, basically this method will get invoked and it will divide the current value of result, which was 4 plus 5, 9 into 3, which was 27. So it is going to divide 27 by 2, which was the last value of the numbers.poll. It is going to execute 27 by 2 and whatever value it gets, it is going to store a value back into the rest variable, and then it is again going to go back here and again going to check the condition if the numbers queue is not empty, but now the numbers queue is empty because 2 was the last element. So it is going to come out of the loop and it is going to print the final result. That is how this whole program is working. Now let's try to see this in action, and we'll try to execute the exact same expression. So if I right click and go to run as and run this as Java application, and I supply an expression saying 4 plus 5 star 3 divide 2. And if I now hit enter, I get the value as 13.5, which is exactly what we ran through, because 4 plus 5 will be evaluated first, which will result into 9. Then 9 into 3 will be 27, and 27 divided by 2 will be 13.5 exactly. So this is how this whole program is running, where we first take the inputs and then we divide the input into numbers and operation arrays, or in fact queues. And once we have those queues built up, then we pick up the first number and we keep running this loop till the numbers queue is not empty. Inside the while loop, at each step, we pick up the first expression or the operator. We check what is the operator, whether it is an addition, subtraction, multiplication, or division operator. And whatever kind of operator we have, we initialize the corresponding class of it. And then we fetch the next value in the numbers queue. And then we call the get result based on the expression. And whatever result we get from the get result, we store it back into the rest variable. So we keep updating the rest variable at every step. So that's the reason the result of 4 plus 5 gets stored in the rest, and next time you are calling the get result for a multiply operation. Here the rest value is 9 now, and it says 9 into 3. Again, in the next time, the rest value will be updated to 27 because we are storing the result back into the result variable. So this is all I want to cover in this particular session, where we looked at an example of a calculator application purely from the console standpoint. Obviously, there can be a lot more stuff which we can do into this particular application, make it more error-free and cover a lot of corner cases like validating the inputs, etc. Also, looking at putting some conditions around the exception handling the divide by zero scenario, etc., which is not here. But this is just to show you the basic idea of how you can build simple to complex CLI applications using the core Java concepts. So in this example, we are going to have a look at a calculator application. And this calculator application supports primarily 4 different operations like addition, subtraction, multiplication, and division. So let's see how do we build that app. So in front of me right now is open the main class. So I have a main app class here, which has a public static void main method. And the first thing we see is a read input class, which is calling a read method. So if you go to the read input class, it has a simple static method here, which is the read method, and it is using the scanner class. If you remember, I talked about the scanner class, which is used to take inputs from the command line from the user. So we initialize the scanner class and we start taking the inputs, and whatever the user inputs in terms of the expression, let's say the user entered 4 plus 5 or whatever, that whole expression gets sent back into this input line as a string. And that comes back here in the input expression. Once we have captured the input expression, the next thing we do is divide the input expression in the numbers and the operators. Basically, an expression would be either something like 4 plus 5 into 3 divided by 2, let's say. Let's say the user entered this expression. So this has either numbers or operators. So that's what we are doing here. We are using the split method of the string API, the string class basically. And this split method is going to split the numbers and operators into 2 different string arrays. And here I'm providing the split expression that split at every time you encounter one of these symbols. So this, when you execute this particular statement, it is going to return a numbers array, which will be created based on this expression. So you will get an array with 4, 5, 3, and 2. And similarly, in the operator array, you are going to split or pick out the elements every time you receive a number. So this operator array is going to hold this plus sign, this multiply sign, and this divide sign. Hope you get the understanding that we are just splitting the whole expression into two different arrays, where first array is holding only the numbers and no mathematical expressions, and second array is just holding the mathematical operators and no numbers. And we'll see why we need to do that in the upcoming lines. Once I've created this string array, I just want to store or convert these string arrays into a queue. So I convert this array into a list by calling the array.asList. So this expression is going to return a list. And then I'm going to convert this normal list into a linked list, and then going to store this linked list into the queue of numbers. And I'm going to do exactly the same thing for the operator array as well, converting this into a generic list, converting that generic list into a linked list, and then storing this linked list as a queue. So I have an operators queue and I have a numbers queue. Both of them have been stored into a queue now. And then I'm using the poll method. If you remember, the poll method of the queue is used when you want to fetch the first front element, the head element of the queue. So whichever element is sitting at the head of the queue will be taken out the moment you call the poll method. So I fetch the first number from the numbers queue. So in this case, 4 will be fetched here in this variable. And after that, I run a loop on the numbers queue. And I'm going to run this particular loop till this particular queue is not empty. If you see, there's a negation here. So I'm going to pick up numbers one by one from this numbers queue till the number queue becomes empty. And inside the loop, I do this exact same poll operation for the operations queue. So this operations queue is holding all these mathematical operations like plus, star, and divide. So I'm going to pick the head of it. So in this case, plus will be picked up and will be stored in this variable called OPR. And then I'm going to run a switch case on this OPR. Basically, as I told you, in this particular calculator application, we are supporting 4 operations, which are addition, subtraction, multiplication, and division. So I define a case for each of the mathematical expression. So you see there are 4 different cases here. And for each case, I'm initializing a class. If it's a plus sign, then I'm initializing the add class. If it's a minus sign, then I'm initializing the subtract class. For multiplication, I have a class called multiply. And for division, I have a class called divide. Let's have a look at what these classes are containing. So if I go to the add class, first of all, it is implementing an interface called operate. And this operate interface has just a single method called getResults, which is accepting a variable argument array. If you remember, I told you that you can also use a var_arg array. This is called a var_arg expression. This means that this numbers will be an array of arbitrary length. It can be a 1-element array, it can be a 2-element array, it can be a 4-element array, or whatever you supply. But it is still going to be a fixed length array, but the length is going to be dependent upon how much argument you supply to this particular method. So that is what this interface operate is doing. It just has one method declared, which is called getResult, which is accepting an array of numbers. So if the add class is implementing the operate interface, then it has to override the getResult method. And here it is just doing a summation of all the numbers which have been supplied. So if you supply 4 numbers, it is just going to add up those 4 numbers and return the sum. And the exact same kind of logic or similar logic will be seen in other operate classes. So if I go to the subtract class, it runs the exact same operation, but it subtracts the values. If I go to the multiply class, it is also implementing the operate interface. And in the getResult, it is just multiplying all the values. Similarly, in the divide class, it is also implementing the operate interface, and it is dividing all the numbers one by one. So it's doing pretty much the same thing in terms of the expression and the logic. The only difference is whether you are using an add operation or a subtract or a multiply or a divide. So we have checked all these classes and the operate interface as well. And let's go back to the main app now. Now you also see that I've defined a reference of operate here, and each of the switch case block, I'm assigning the object type to this interface reference. So I'm using the concept of dynamic binding, which we talked about when we talked about interfaces, that we can also do dynamic binding where we can assign an object to an interface type. and the object type will depend upon the expression. So once we have filled that based on the case, while filtering out this expression and picking up plus, star, and divide sequentially, then we go to the next line outside the switch case block, which is to pick the next number from the queue. Remember, we already did one poll here. So as per this example, 4 was here in this res. And now when we do this number.poll again, 5 will be picked up because that will be the next head of the queue. So we pick up 5 here, and then we call operate.getResult. Now this getResult will be called based on the expression which was encountered first in the queue. Again, looking at the example, the first expression encountered will be plus. So the expression was plus. So the operate type object is of add type. And when you call operate.getResult, the getResult method of add class is going to get invoked, and it is going to sum 4 and 5. This res is holding 4 right now based on what I described here, numbers.poll. And this num is holding the second operand, basically 5 here. So 4 plus 5 gets evaluated here in this case. And then it again goes back here and it checks if the number queue is now empty. No, it is still not empty because we still have 3 and 2 left there. So again, it does the operations.poll and it picks up multiply sign here. Then it again runs the switch case. Since it's a multiply sign, it will go here and it will initialize the operate interface reference as the object of multiply class. Then coming here, it will do a numbers.poll. And this time the numbers.poll is going to pick up 3. So 3 will be picked up here. And then the current value of result, which is already 9, 4 plus 5 was 9. The current value of result will be updated here. So res will be 9 here and num will be 3 here. And when you call operate.getResult, the multiply classes getResult will get called and it will say 9 into 3, which will become 27. It will again go back here to this particular line and it will check again if the numbers queue is now empty. No, it is still not empty because we still have one element left. Then it polls the queue of the operations where the expression divide is present there, which is the only element left in this particular operations queue. And since we have the OPR value as divide, this case block gets called and the new divide class gets initialized. The divide class basically gets initialized and we come here and we do numbers.poll. Now the last number which is available in this queue is 2, which gets picked up here. And then we again call operate.getResult. This time, since the operate operate reference type was of divide class type, so when we call operate.getResult, the divide operation or the getResult method of the divide class, basically this method will get invoked and it will divide the current value of result, which was 4 plus 5, 9 into 3, which was 27. So it is going to divide 27 by 2, which was the last value of the numbers.poll. So it is going to execute 27 by 2 and whatever value it gets, it is going to store the result value back into the rest variable. And then it is again going to go back here and again going to check the condition if the numbers queue is not empty, but now the numbers queue is empty because 2 was the last element. So it is going to come out of the loop and it is going to print the final result. That is how this whole program is working. Now let's try to see this in action and we'll try to execute the exact same expression. So if I right click and go to run as and run this as Java application and I supply an expression saying 4 plus 5 star 3 divide 2. And if I now hit enter, I get the value as 13.5, which is exactly what we ran through because 4 plus 5 will be evaluated first, which will result into 9. Then 9 into 3 will be 27 and 27 divided by 2 will be 13.5 exactly. So this is how this whole program is running, where we first take the inputs and then we divide the input into numbers and operation arrays or in fact queues. And once we have those queues built up, then we pick up the first number and we keep running this loop till the numbers queue is not empty. Inside the while loop, at each step, we pick up the first expression or the operator. We check what is the operator, whether it is an addition, subtraction, multiplication, or division operator. And whatever kind of operator we have, we initialize the corresponding class of it. And then we fetch the next value in the numbers queue. And then we call the getResult based on the expression, and whatever result we get from the get result, we store it back into the rest variable. So we keep updating the rest variable at every step. That's the reason the result of 4 plus 5 gets stored in the rest, and next time you are calling the get result for a multiply operation, here the rest value is 9 now, and it says 9 into 3. Again, in the next time, the rest value will be updated to 27 because we are storing the result back into the result variable. So this is all I want to cover in this particular session, where we looked at an example of a calculator application purely from the console standpoint. Obviously, there can be a lot more stuff which we can do into this particular application, make it more error-free and cover a lot of corner cases like validating the inputs, etc. Also, looking at putting some conditions around the exception handling the divide by zero scenario, etc., which is not here. But this is just to show you the basic idea of how you can build simple to complex CLI applications using the core Java concepts. Let's get started with Spring Boot and how we can build a simple application using Spring Boot. Before we go further, let's understand why we need Spring Boot. And the basic idea of Spring Boot is to build RESTful web services. If you want to know more about what are RESTful services, please, you can read about the RESTful concept. As a concept, what does REST stand for? But the basic idea is that if you are accessing anything over HTTP, then that particular component can be built as a RESTful component. And Spring Boot is the most popular choice for building RESTful web services today. And even in fact, microservices, which you might have heard about. So you can build microservices which also run on HTTPs using Spring Boot. So what I'm showing you right now is the official guide of Spring, which you can use to build an application with Spring Boot. It will list down all the requisites which you need in terms of the JDK installations, Maven, and how to complete this guide, etc., etc. You can again use the same Spring initializer which I talked about in the previous session. You can use this to generate a Spring Boot project for you specifically. So all those options are available here. So I've already done that, and I'm not going to repeat what I just did in the previous session, and will directly jump to an IDE where I have created a sample Spring Boot application. And the structure here, you can see the structure would look very similar with one change, that in the previous example, when we were dealing with MVC, we had an src main resources folder, and that src main resources folder was having all the web components or the HTMLs. But since in RESTful web services, you do not render the HTML, but you just send back the response. The response body can be pure XML or it can be pure JSON, but you do not send back an view, and that's the main difference between Spring MVC and Spring Boot. That in Spring MVC, you are required to return a view technology. Like in the previous session, we sent a die-mylif template, which is basically an HTML. You can also return a JSP, but with Spring Boot, you do not deal with the view technology. And that's the world we are living in today. When you write Spring Boot, you do not have to worry about how this is going to be rendered on the web page, whether it is going to be rendered using HTML or whatnot. What you need to take care of using Spring Boot is to return the right response body, the exact text of the response, and that's it. So with that in mind, the Spring Boot was born, and the structure, apart from that, the structure would look very similar. There's a pom.xml here, which will provide all the list of jars and dependencies which are required for this particular project. So you can see all the dependencies here, pretty much the similar ones. We have a starter web, we have a starters test, and we have a Spring Boot Maven plugin. And we have an application file, which is the entry point, again having a public static void main method. So you need to put the @Spring Boot application at the top of the class to make it an entry point. If you don't do this, Spring Boot will not run this class, and Spring Boot will even not run your application. So what we are doing as part of this example, that we are just printing all the beans which are provided by Spring. That's all we are doing. Like I said, it's a very lightweight and an introductory session, so we will keep the logics to minimum. And I'm just getting all the bean definitions, sorting the bean definitions, and just printing them one by one. How do you get the bean definition? You get that with this application context class, which is returned when you run the application. And how you run the application is basically using this line where you say Spring application dot run, and you supply application dot class with any command line arguments which you might want to use. Once you do this, it is going to return an application context object to you, and the application context object can be used to get all the bean definitions by calling this method which says get bean definition names. So that's the basic logic which is being run in the main class. Now we also have a controller, but this time it's not a web controller, but it's a REST controller. So you see, in the previous example, we just had written something like this. It was just a pure controller. But here we have become more specific. We are saying that, hey, this is not a simple MVC controller, but this is a Spring Boot controller, or technically a REST controller. So Spring provides a separate annotation for that, which is @REST controller. So you write that particular annotation on the top of the controller class which you are creating, and then you provide a request mapping similar to what we did in Spring MVC. But while you return it, you do not return a view technology. You just return the raw response. Here I'm just returning a string, but you can return a JSON object, you can return an XML object, or whatever you want to, but not a view technology. That's what I'm doing. Like you can see, there's literally nothing I'm doing in this. It's just a simple string return statement which I've printed here. And that's all the code I have right now here. I just have these two classes. Okay, so that was all about what I have written in the project, and now it's time to run the project. So I have just reached to the location inside my terminal where the project's pom.xml was present, and if I just do an ls, you will see that there is a pom.xml available here, and all the code directories are also available here. So now I will just run this application, and to run this application I'm just going to type mvn spring-boot: run and hit enter. Once I do that, the Spring Boot application is going to get started, and let's go back to the controller and actually the main endpoint and see what we were doing there. I did a sysout here which said let's inspect the beans provided by Spring Boot, and then I was printing all the bean names. And if I go back to the output, I will see the same line being written here, which was around let's inspect the beans. So you can see that message which says let's inspect the beans provided by Spring Boot, and then all the beans which are available in the application context are printed here. So that's the basic idea which I want to give you, that you can actually build a Spring Boot application, and you can write your REST controllers, return a string body from it, and once this is run, then you can also run your application from the web browser as well. So let's try to hit that particular URL which I wrote here. So the URL of hello country. So for that, let me just open a new Cognito window, and our application is already running. So if I just say http localhost 8080/, I get this message here which says greetings from Spring Boot, and this is the message which we were sending from the REST controller. So this validates our understanding that we can invoke a REST controller, which is a Spring Boot REST controller, via the same method, but this time we are not getting an HTML, but we are just returning this particular string. Now you can use the string in any ways you want, so it depends upon the consumer. So that's all I want to cover as part of the Spring Boot. Now Spring Boot is a huge topic, and we can spend hours and hours talking about Spring Boot, but since this is more of an introductory session, so I just wanted the concept to get introduced, and remember the value proposition of why you would need Spring Boot. The basic idea is to build RESTful web services or build RESTful microservices. That's the basic idea behind using Spring Boot in your applications. And also remember the difference between Spring MVC application and Spring Boot application. Spring MVC is for building web application. Spring Boot is for building RESTful applications which might not have a web interface integrated with them at that moment. Let's get started with our demo of a project which is using Spring Boot to build a RESTful web service. So a RESTful web service is nothing but any endpoint which you can access or you can consume the data from via an HTTP layer or via simply a web layer, because most of the web traffic which we deal with is built on HTTP. So to take an example, if you go to any website where you sometimes see on the top right corner, you see today's weather. So how is that today's weather coming in? It's coming in via a REST web service. the website which you are accessing is basically hitting an HTTP endpoint, which is where the weather application is sitting, and it asks for the weather data, and the REST web application just returns the data, and that's how the website is able to show you the current weather. So RESTful web services are everywhere, and they are the most popular way to build applications today, where you just build your RESTful web service and you expose an HTTP URL. And then the consumers need to just access that HTTP URL to consume the data from your application. And you see, this makes it very easy because there is no data type restrictions. There is no tight coupling here. It's just an HTTP endpoint. So that's the basic idea. And we will look at a project where we will be using Spring Boot to build a RESTful web service. And then we will try to run that web service to save some data and also to return some data. So here on the package explorer, you see I have created a project called REST service. And let's just walk through the structure of it, and then we'll go into the details of it. So we have an src main Java where I have a package, and I have a bunch of classes here. And before we go to the classes, let's first also access the dependency file, because every project needs some dependencies, some jars to execute it. For example, Spring itself is basically a jar. So you need to include the Spring jar in your project so that your project can become a Spring project. And there are generally two dependency tools. One is Maven and one is Gradle. In this particular project, I am using Maven dependency tool for downloading and managing the dependencies which are needed to run this project successfully. And the way you will find if it's a Maven project or if it's a Gradle project, for a Maven project, you will see a file called pom.xml. And if it's a Gradle project, you will see a .gradle file. That's how you can spot whether the project is using Maven for dependency management or it is using Gradle for dependency management. So let's open the pom.xml. Since it's an XML file, it will be a bit verbose, but if you just read it piece by piece, it will become easier to understand. First of all, since this is a Spring project, I need to include the parent dependency, which brings a lot of good defaults, sensible defaults from Spring Boot automatically. And this is the jar name. This is the artifact ID, which is Spring Boot starter parent. So any Spring Boot project you are starting, do include this parent. This parent is basically bringing all the dependencies from some other jar, and you can make your project as a child of this particular parent. So all the Spring Boot projects have this as a parent as a standard practice. After that, you provide your own details in terms of what is the package name, how do you want to see the jar name, and what is the jar actual name, what is the jar version, etc., etc. You also set the minimum required Java version to run this application. And then in the dependency sections, you provide all the jars which you need to run your project successfully, both compile and run your project successfully. So we added the Spring Boot starter web dependency, which basically brings all the dependencies around making a controller or making a repository, context component scan, all the interesting features which Spring provides get wrapped up inside the Spring Boot starter jar. And you can actually go to the MVN repository and have a look at what all classes it provides. It's a lot of classes. So I'm just telling you in a brief that it provides all the RESTful functionality. Then you have the next dependency as Spring Boot starter data JPA, which is going to enable this project to also have a database. And if it has a database, then you need Java to talk to the database. And the way Spring suggests to talk to the database is via using the Spring Boot Data JPA library. We will see how this library can be used, but basically this provides ways to represent your Java object in the database. And then you need to also add the actual dependency of the database. And in this case, we are using an in-memory H2 database. So I'm not using an external database like MySQL or Oracle or PostgreSQL, because that will just make more configurations more complicated. I just wanted to keep it simple. And generally, in this H2 database, you can easily access by adding this dependency, and it will be an in-memory database created for you. Then I've also added Spring Boot starter test here, which will be used whenever you're writing unit tests, and you must write unit test for your project. And then we need to add the plugin so that Spring Boot can run this project. That's all I have in the pom.xml. Now let's move to the interesting part, the Java section part. Let's start from the main class. So this is how the main class looks like, where you just create any name with the class, and then you add a public static void main method. Inside the public static void main method, you call Spring application dot run, And this run method is basically going to run your application, and you just provide the same class name which you just wrote here. So you just say dot class. And if you're supplying any command line arguments, it can interpret that command line arguments as well if you want. So you'd always need an entry point in an application, and this is the entry point which Spring Boot supports. And this is, if you see this code, this is just normal code. To make Spring be aware about this class being treated as an entry point, you need to add @Spring Boot application annotation on top of the class. This is one of the annotation which is coming directly from the Spring Boot library. You can see this import. So once you add this, then only Spring will be able to treat this class as an entry point. Otherwise, Spring doesn't know where to start from. So when you run Spring, it will try to find a class with an annotation Spring Boot application, and then inside the class, it will try to find a public static void main method. And once it has found both of them, then it will just run the application. So it's very simple, nothing fancy here. And what we are dealing with here is a student object. So we will try to insert a student object, and we will try to retrieve the student object. So if you ignore these annotations which I've added, it's just a pure POJO. It's just a plain old Java object. You create a student class. Let's ignore this field as well for now. I'll just come back to this annotation in this field. But this is just a student class. It has 3 fields as name, age, and address, an empty constructor, and a parameterized constructor, and some getters. Intentionally, I have removed the setters because generally, whenever you are building any enterprise grade application, you would like to keep your objects immutable. Means once they have been created, you would not like somebody to allow to change the values of the object. This just makes programming much more easy if you treat all the objects in your application as immutable. That's why I have not added setters here. It's just considered a good practice. So apart from the standard things which we have already seen, there are 2 things here which I want to talk about. Let's first talk about this one. So @entity is the annotation which is coming from Java X persistence entity. And this makes Spring Boot save this particular object into the database. This is the annotation which you need to put on your class so that Spring Boot knows that this class represents a table in the database. So you need to add this to make sure that this represents a table. Second thing, a table will have a ID. It will have sort of a primary key. So I've created a new column called ID, which is basically representing the student's roll number or something, or maybe a registration number. And here I'm using a couple of more annotations. If you see, these annotations are also coming from Java X persistence library. And these annotations will basically allow a new ID to be created every time you create a student object. So you don't have to specify the value of this ID variable. Spring Boot will automatically generate a new ID value every time you create a new student object. And how does it generate? You can provide the generation type as well. So currently I've just set it as automatic, but you can set it as identity, sequence, or controlled by table. You can also see the explanation of each of these here. But I've just kept it as auto, which basically let the persistence provider pick any appropriate strategy for the particular database. In our case, the database is H2. So that's about the entity class. Let's call this as entity class. Now let's move to the repository. So you need a repository class. Like I explained in that 3-tier architecture, you always need a DAO layer or a repository layer to store your student object into the database. So we have enabled the student object to be saved, but we need a handler which can save this particular file, this particular object into the database. And the repository classes are the classes which will allow you to do that. So you create a very simple interface. You name whatever you want to name your interface as, and then you say extends JPA repository, the type of the object, and the unique identifier of the object. So the type of the object is student here, and the unique identifier of the student object is the ID, which is of type long. So you need to just supply the types: type of the object, type of the primary key, or the type of the unique identifier. And this annotation is coming from Spring Boot. You can see specifically Spring Boot data library, which we added. So you just need to create an interface, extend it from JPA repository, and make sure that you add this annotation as well. Spring heavily uses the concept of annotations, and this will help Spring understand that this is a repository layer class, and it will apply some more metadata to this class while this class is running in the JVM. So what happens here? You just created an interface. You did not provide any method to create or any method to delete or any method to get a student object, because all of that is automatically provided by Spring Boot via the JPA repository repository class. If we go inside this class, and if you scroll down, you will see the find all method, find all by ID, save all, flush, save and flush, delete, etc. And if you go further up, this also extends the paging and sorting repository, which provides pagination and sorting facilities. But the interesting one is that paging and sorting repository again extends a CRUD repository. And if you go to the CRUD repository, you will find all the basic methods to save an entity, save multiple entities, find an entity by the ID. That's why it needed that long type to make sure that it can execute this method. You can check the existence of an object, find all the entries, find all by ID, count them, delete them. So all the basic CRUD functionality. So we call them as CRUD because the reason it is called CRUD because create, read, update, delete. That's basically the generic acronym. So because this CRUD repository provides all the methods and their implementations automatically, we do not need to write any code at all. So that's why Spring Boot is so awesome, and that's why Spring Boot is very popular, because it's zero code in the repository and you still get all the CRUD functionality. So that's about repository. Now we have covered the entity class, we have covered the repository class, we have covered the entry point class. Now the only thing which is remaining is the endpoint, the HTTP endpoint, which I talked about. And that you can create by creating any class. Generally try to suffix it with the controller so that your code developers can easily find this class. And make sure that you put @REST controller annotation on top of it. This annotation will allow Spring to treat this particular class as an endpoint class. Then you can auto-wire the student repository. So if you remember, I talked about the whole dependency injection and inversion of control. So here dependency injection is in action. So here you're just telling student controller to auto-wire the student repository. And now what will happen that at runtime, student controller, or actually Spring, will automatically create an object of the student repository and supply that object of student repository to student controller. So you as developer do not have to create an object of student repository explicitly. That's the benefit, and that's how the dependency injection is working, because you inverted the dependencies now. The dependency is just injected into the class, and as a developer, you don't have to take control of creating the objects. It's the Spring which will automatically read the auto-word annotation and will automatically supply an object whenever it is required. Then I have two methods here since we are talking about HTTP endpoints. So I have represented a post method here and a get method here. The way you will write a post method is via @post mapping annotation. And then you can provide the URL path on which somebody should call your endpoint to save something. So for example, somebody can call it HTTP localhost 8080/student/create. Whenever they hit that URL, the control or that request will directly hit this particular method. Why? Because you have provided the URL mapping here in the post mapping annotation. So since it's a post method, there would be request body. What is the actual request body which the client is sending? And you can represent that request body with the @request body annotation. And you can provide the type of the request body. And here I'm saying that, hey, if you want to access this particular URL, yes, all good, but you need to supply me with a text representation of the student object or a JSON representation of the student object. And then inside the method, I'm calling student repository dot save, which is going to save the student object which is coming in. So you see there's a lot going on here. I will show you how the student is represented in the request body as well. And then I will come back to how it got converted from JSON to Java. But this is how you can store this particular student object. You can hit this API as many times as you want and keep inserting a new student object every time. Then if you want to fetch a particular student, then you can do that by supplying the /student. And then in the curly braces, there's an ID written here. So basically you can supply the value of the ID of the student. So generally there would be another method here, which would be find all, to see all the students and with their ID, and then you can pick a particular student's ID, supply that student ID value here dynamically. That's why the curly braces supports dynamic value. So here it can insert 1, 2, 3, or whatever the student ID you want to fetch the value for. You provide that value in the student/ID, and all good. Then if somebody is hitting the URL with saying localhost 8080/student/1, then student with the ID 1 will be returned from the request. And you need to put @get mapping to make sure that this method is treated as an HTTP get method. And you can provide the type, you can say get student, and here this dynamic value is captured with the @path variable, because you need to know the ID, right? Whatever ID somebody has supplied it in the URL, you need to capture that IDE and then use that IDE for calling the repository. So you can do that by using the @path variable. So here I'm just saying whatever ID is coming in, I will store that value inside this IDE. Once I've done that, then I can again call student repository dot find by ID, which is again a built-in method provided to me by the CRUD repository. I can supply the ID, and this actually is going to return an optional object, which is an object which may or may not contain a value. So it's just a defensive programming style. So this will return an optional, and you can call a get method to return the actual student object. This will return an optional of student. So optional of student means that this optional object may have a student or may not have a student. Why did Spring do that? Because the ID somebody is supplying, that ID can be invalid also, right? So optional object takes care of that if there is no student found, then you will not get a null pointer exception. And if there's a student found, you can return that. So it's just a defensive programming style which Spring has adopted by returning an optional of the student object rather than directly the student object. But if you're confident that this particular optional of student object does contain a student object, then just call optional.get, which I've called here, which will return the actual student object sitting inside the optional object. You can read more about the optional object and its usage from the official Java docs, and there are tons of examples available on it on internet. So this is about the controller. We have covered all the classes. Now it's time to run the application. So you go to the command prompt, you go to the particular file folder location, and there you just say mvn spring-boot:run. So I just hit enter, and this is going to run the application. It's going to spit some logs here, and if everything is fine, you will not get an error, and you will just be getting a message saying that application got started. And it's running on Tomcat localhost 8080 with no context URL. So this is not a web application. This is a RESTful web service, right? This is a RESTful service. This is not a web application. So there is no web interface. So how do you access this? You just have an HTTP URL. So you can use any of the REST client available on the internet. There are probably hundreds of different REST clients available on the internet. You can choose any one of them. I am using advanced REST client, which you can also install as an extension from the Chrome browser itself. So if I just open the Chrome browser and I just say REST client, if you just write this and hit enter, you will get many different options. And the first option you get is from Google Play Store's App Store. So you can go to the App Store, basically the Chrome Web Store, not the Play Store, but the Chrome Web Store, and you can just install this. Since this is already installed, you can click on Launch App, and it will open this interface for you. So this is this is not a tutorial for advanced REST client, so I'll just be quick here. You can choose the method type which you want to hit. So let's say I want to do a post, and then you can provide the URL here. So remember the URL which we put here in the controller method, this has to exactly match. So HTTP localhost /student/create should be the URL. So let me just copy paste this one here. Okay, so the URL is good here. It's a post type of method which I want to do, and I want to hit this particular URL. Now I need to supply the content type and the body. So in the content type, you can choose application JSON because I'm going to supply a JSON object. And in the body, this is how the JSON object looks like. Advanced REST client also provides a nice visual interface to basically create this JSON. If you are thinking that JSON creation is very tough, it's not actually tough. It's just curly braces. And then you put key and value, comma, let me just put an enter here so that it's more readable. So you just put curly braces starting and end, and then you just put key value. You put a key, which is the variable name, and the variable's value, variable name, variable value. And these keys have to exactly match the student's properties. So the student.java had this name, age, and address, right? So it has to exactly match. Otherwise, this request will fail. So this is all good. Now I can send this particular request. When you click send, it is going to hit my Spring Boot application, which is running on localhost 8080. It is going to call the student/create method. It is also going to convert this JSON into a Java object because here I'm supplying a Java object. So it will convert the JSON, which I'm sending from here, to Java object automatically, and it is going to automatically save it here because I've called the repository.save method. So let's hit send here. Once I hit send, I get a 200 OK. It means everything went fine. And in the response header, I get the object back because I have returned the object here. You see, this save method is going to return the same student object which you created. So everything is good here. My object has been stored here. And now it's time to fetch the object. So it has already been saved into the H2 in-memory database, and you can obviously go and connect to the in-memory H2 database and have a look at it. But for simplicity, I'm just going to do this here. And let's say the first object is generally added as the ID1 by default by the H2 database. So let's hit this particular URL. When I hit this URL, it is going to hit the student controller here. And in the student controller, it is going to hit the getStudent method, which is having a student/ID URL. And it is going to find the database with that ID. And if it finds a student object with that ID, it is going to return that. So let's confirm that now. So let's hit this particular send button, and it is going to hit a get request with this particular URL. Spring Boot is going to find if a student with the ID 1 exists in its database. So once I hit send, I get a 200 OK. And you see in the response headers, I get the same student object back, which I added. Let's try with 2 now. Let's see what happens. I see 2 and I get 500 internal server error because there is no object stored in the H2 database of the Spring application with the ID 2 yet, because we only inserted one object. That's why only one student object is there, and the first ID which H2 database created for it automatically was 1. So when you hit for get request with a student ID 1, you get the object. When you put any invalid value and you hit this, you get a 500 internal server error. You can also make it look nice by not sending the 500 internal server error and sending a nice exception from the backend. So from here, you can also send a nice exception that if this object is not found, you can say something like that, or else throw, which is again an optional object. And here you can supply a particular type of exception which you want to supply instead of just throwing 500 internal server error. But that's just additional defensive programming you can do. You can add more and more validations and constraints into this project as you build this project in a more complex paradigm. So this is basically what I wanted to show you, that that we have created a Spring Boot application. We have connected it to a database. We have created also an HTTP endpoint with student controller. We ran that application. We used any random REST client. In my case, I used advanced REST client. And we first did a post request. We provided the exact URL. The URL has to exactly match with the controller URL. And then the body, the request body also has to exactly match with the student object's property, especially the case of the names have to exactly match. So if all this matches, then you will get a response back that the object has been created. If you want to fetch the value of the object, you're going to use the HTTP get method, and you again provide a URL which has to exactly match to some method in some controller in the Spring Boot application, which is running on localhost. And if you provide the right ID, you are going to get a valid result. If you provide an invalid ID, you're going to get a 500 internal server error. And from here on, you can make this controller as robust and as mature as you want. You can add find all method. You can add a update student method. You can add a delete student method. You can have all different kinds of filters. Like, for example, return to me all the students starting with the name A, or return all the first students with the roll number 1 and 100, or between 1 and 100. So you can write as many endpoints as you want and build this application in with as much maturity and as much complexity as you want.
Now with that, we have come to an end of this exciting session on Java projects for 2022. I hope you had a wonderful and interesting session. And if you have any queries regarding any of the topics covered in this session, or if you require the resources that we have used in this session, then please feel free to let us know in the comment section below, and our team of experts will be more than happy to resolve all your queries at the earliest. Until next time, thank you, stay safe, and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.